Hello everyone, thanks for joining. In this session, we'll be talking about walking through identifying and drilling into a slowdown in MongoDB and what are all the different reasons behind that and how you can overcome them, right? So before jumping into the slides, I would like to introduce myself. My name is Divyanshu Soni and I'm from Noida, India. Before jumping into the slides, I would like to introduce myself. My name is Divyanshu Soni, and I'm working with Percona in managed services since last couple of years. And I have like overall 5.5 years of experience, primarily as a MongoDB database engineer. So I hope this session will be helpful for you to overcome those issues which you might face in your database. So this is how our agenda will look like. We'll be going through each topic one after another so that you will be stay connected what are we going to discuss in the remaining slides and the entire sessions. So the agenda will start with always follow proper and systematic approach while initiating your troubleshooting. This is mainly important to save precious amount of time if you are encountered some critical issues in your database and you have to directly jump into it. And in order to fix it, you will sometimes have very minimum amount of time to spend, directly you need to fix the problem. So always follow a proper and systematic approach, in order to find out the exact issues. So we'll be taking a look on how to do that one by one later in the slides. The next is reasons behind slowdown and performance issues. What could be the reasons behind them? And do not get confused between the root cause and symptoms. This is an important one where people tends to get confused by the symptoms, and they actually think that this is the root cause, which is eventually is not, right? So, and the next we'll be exploring a few PMM dashboards, Percona monitoring and management dashboards, which is our open source monitoring tool to help identify the different areas where the issues could arise, and it basically helps you out to find out the exact issues. And we'll also be exploring query analytics as well in order to find some culprit queries, which is part of your workload, which might have contributed to this a particular issue, right? And the next is always plan ahead of time. That is need for scalability, which is also important factor, because you don't want to jump into a situation wherein you are kind of stuck, right? You already hit the saturation, you have already the saturation point of your available cluster resources. Then uh, it's always takes time to upscale. It cannot just you cannot just go ahead and upscale your entire database. It's not happening in that way. So it takes time, and time is also precious if you're facing a critical issues, right? And last but not the least is best practices are constantly improving, right? So it's all those best practices which we'll be following and which we'll be taking care of are not just limited to what we are going through the session. There might be others, and in the future that might improve the overall performance. So we should always be constantly improving on what are the best practices we are following, right? And these are all the key points which we'll be taking a look that will eventually be helpful in order to find out the culprits and find out the actual issues and actual reasons behind that Solana software database. So the first one is the unoptimized workload. And by unoptimized workload, I meant to say that, let's say, if you have developed some kind of a services, and without even performing a load test on top of that, you have directly deployed in the production. You are not aware of how your production cluster will behave if you actually deployed them directly on top of that cluster, right? So that could potentially result in the operations which are hitting from the client to the database server, requesting a lot of data, which in actuality which in actual the server is not able to handle, right? So this is one of the reason. Another is, let's say in the same deployment you have lots of aggregations queries running concurrently, which is obviously an expensive operation. If they are not optimized on top of that, it will eventually add more bottlenecks for you, right? Another thing are the collection scan. If you have a lot of collection scan coming up, they will eventually create a lot of disk issues, right? And the next is burst in connection, right? If there are lot of connection gets opened against your database, that also contribute into that issues. So you need to take care of looking into what are all the unused or idle connections that are being established. So try to get rid of them if at all possible to save some resources. And you're taking a look in those things in the latest size in depth, so we'll get an idea for that. Not using connection pooling, let's say if you're directly establishing new connection altogether, that also adds an overhead for your database to serve those new incoming requests, right, for every connections. The last is the pin cursors or uncommitted transactions. Oh, let's say if you have fired a query with a cursor, you haven't added a timeout or direct explicitly specified a no cursor timeout, so you kind of pin that cursor to be opened without any timeouts. So that will also create a bit of an issue for you because it sets an overhead for the resources. And uncommitted transaction as well, like if you open a transaction, if you haven't aborted it or committed it, it will holds a lock for that particular amount of records, right? And the next is overwhelming cluster with heavy concurrent requests. Let's say uh, if you're running a concurrent, highly concurrent operations, it could be either read or write operations that could potentially exhausted all the white tagger tickets, right? So if you are aware of the concurrency tickets which are available in white tagger story engine, which are 128 for reads and 128 for writes. So let's say at a certain point of time you have consumed all of them, right? So any operations that are new and coming up trying to hit your database will end up in the queue because they are not getting any free tickets at that moment of time. So what you need to do, you need to figure out how you can improve those operations which are taking a lot of time and consuming those tickets at all, right? So if you can serve that traffic in a better way, in an optimized way, that will eventually going to help you out, right? So database model itself is not optimal. What it does means is, let's say, if you have embedded structure of database model, even though MongoDB is schemaless, but still you have to take care of sometimes designing your document model, how it looks like based on your query patterns, right? So let's say if you have embedded model of documents, right? Uh, Large array fields, right? So what happens, let's say if you are doing a lot of updates, if you, and at the same time, if you have a large arrays in your documents, so for each and every update, that particular array which is going to be updated has to be, has to be stored in a form of document while the update is going on, and then later once the update is finished, that has to be reverted back to the original state after you inserted a few more values into your arrays, right? And another thing is, let's say if you have in the same document structure, you are basically looking to carry few certain fields uh, and not the array one. But until unless you're not projecting out that particular array field, you will be getting the entire document to the result set unnecessarily. So that also becomes your part of your working set, right? You don't want to you don't want to use that. You don't want to run into those kind of issues where unnecessarily utilizing your resources. The next is nested data and documents are rarely accessed but still become part of it. Working set, that's what I said just now. And the last but not least is hitting large document size or limit of 16 MB. Let's say initially you have, okay, you have multiple array fields and multiple nested documents. And then later in the near future, you went to an issue wherein you cannot update that particular document wherein you have already reached the certain limit of 16 MB. Then you have to remodel your entire database because you have to now split those documents so that new fields can be stored in that, right? Now, where to look for all these things? You can take a look in a current of what, so that's happening in the real time. So you can take a look what exactly happening if there is any operation which is waiting for the lock and which is running from a certain period of time, let's say in few milliseconds or taking more than a minute or some kind of a thing. So for a short-term solution, if you can try to kill those operations, if that are not hampering your business, then it should be fine. But for a long-term solution, you have to think why they are taking so much time to execute, right? Because eventually that's what I've said in the previous slides, that uh, it will create an issue for your concurrencies, right? So remaining operation will end up in the queue if the already existing operations are running very slow. The next is server status. So in this particular server status command, you can look for white tag tickets utilization. That's what I said. Also, if there are no tickets utilization, that means that your queue will start to increase, right? If the entire 128 tickets for the read and writes will be exhausted, right? So you need to take care of that. But end goal would be to optimize your workload. If it is not optimized, we will directly deploy some kind of new services. So eventually you will start seeing increase in queue, increase in connections, right? Because the previous connection were not able to serve the request fully back to the client. Next is metrics. So you can like see how many operations are currently running on, right? And if there is, you can look for the op counters as well, like how many inserts, updates, and deletes and finds are currently active against your database, right? In metrics, you can see the cursors of entire things about cursor, like if there are any pinned cursors, right? All sort of things. And the next is PMM dashboard. So this is very handy uh, if you have gone through PMM earlier. So there are several dashboards available which will eventually help out to find out the exact issue at a certain point of time, right? And in order to review our workload, review our cluster performance over the period of time. So we'll be going through all these dashboards one by one in depth in a bit. And the next point is hitting resources bottleneck, which basically means that you have completely exhausted all the resources available for your server. And by resources, I meant to say that the amount of CPU available, CPU cores available, the amount of memory available for your server, the kind of a disk available, the disk IO available for your server, right? So all those things, if you have utilized, then eventually you will start seeing a significant drop in your database performance. So there could be many reasons behind hitting those bottlenecks. So there could be different trends, right? If you are seeing a sudden spike that maybe spiked on a certain point of time each and every day, then you can need to find out that certain point of time and find out what are all the offending operations running at the same time. And if it's continuously growing over the period of time, that you know that there is a certain issue that is might be happening. So depends on what kind of a trend is happening in your matrices. Based on that, you need to take certain actions, right? So anyways, behind the spikes in CPU utilization, the majority of the times, the issue could be the culprit queries. The queries which are executing against database are not at all indexed, right? And they are doing a heavy collection scan. They are doing a lot of sorting, and they are doing a lot of aggregations, right? So those because the CPU has most of the times has just one work has to do once it gets documents from the disk, if it's not served from the cache layer, right? It needs to bring the document from the disk back to the cache and needs to perform a lot of compression, decompression as well, right? So a lot of computation resources will be required for that. And let's say if you're doing heavy sorting, it has to sort all those results before actually sending back to the client. And another important thing is, let's say if you have an aggregation pipeline stage that is unwind as on a large scale of array, right? Same with the lookups. If you're performing a lot of lookups, and if you have hitting too many connections at the same time, right, that will contribute to that certain issue of CPU utilization. Another thing is disk latency, which is also important, which I personally found out that it's a bit overlooked most of the times. Uh, Basically, if you are seeing high latencies in the disk metrics going beyond 1 millisecond or more than that, most of the time, that it means that your disk is not able to cope up with the workload, is not able to handle the request comings from the database side, right? So that eventually contributes if you're seeing a lot of IO waits as well, right? And the next is high disk I utilization. Let's say if you have certain amount of IOPS available for the data disk, which you have been using for the MongoDB. So based on that, if it's reaching the certain saturation point of, let's say, more than 90% majority of the time, right, then you mean that you are basically hitting the bottleneck of your disk, which is the worst kind of a issue that you can face for your database. So there could be many reasons, like similar reason of the large queries doing collection scan, which are involving a lot of disk IOs most of the times, which contributes to the lot of disk IO. And even if you have a lot of write operations which are disk bound majority of the times, then also you can see the high disk IO utilizations, right? So in heavy read disk bound workloads, which means that you have a high read workload which is not being served from your cache, which is significantly faster as compared to disk, as we all know. That could also be the reason. Another is if you are seeing a lot of wiretagger cache eviction and wiretagger cache activities. This basically means your cache is not sufficient enough to handle that workload or handle the amount of data set that you are dealing with. So every time a new query is being firing, it has to go to disk, bring all the records back to the cache, and cache is already on its maximum usage, right? It has to flush out the least recently used pages to create some space for the new records that are coming from the disk, right? So that involves a lot of wiretagger cache activity, and there will be a lot of disk IO as well at the same time, along with what the query is actually doing for serving that request. Because of all those reasons, your queries per second gets throttled, right? Your requests per second gets throttled, throughput reduces a lot because of the same reason. That is basically because of your over the period of time, your working set is not able to fit within your wiretagger cache. What it means that every time you are firing a query which is already not being served from the cache, it has to go to disk and then create some space in order to hold them for the later use, and then send the response back to the client. So to take care of all those things, let me just show you an important thing while running a query so that it will be helpful for you. So this is how the PMM dashboard will look like, and there's the home page. So if you can see, there are several dashboards available which have different roles. So I'll be going through a few of them one by one so that we'll get an idea. So this is the instance overview, MongoDB instance overview, which will give you an insights about what exactly happening on top of the database rather than on the story engine level. So if you click on this one, you will be seeing a lot of different options. So currently I have just one particular cluster. So I will, it's already defaults to that one. And you can even select the time frame. Let's say last 3 hours if I've selected. So as you can see, this kind of a pattern here, right? So number of connections. So if you're seeing a certain spike in that, you know that there might be some offending operations or offending services that have been deployed from the application side. Similarly, for the cursors, if you are seeing a lot of pinned cursor, like I mentioned, utilize a lot of resources. And similarly, queued operations, document operations, like how many documents are being basically the type of operation that is executing currently. Similarly, the query efficiency as well, how efficient a query if it's being doing a collection scan or doing index scan, right? And remaining metrics is also important, such as your page fault, right? If there is a page fault, that basically means that you are involving a lot of disk, which is eventually not good for you. The next important metrics is wiretagger details, which I personally found very important, not just limited to disk or memory matrices. So same, you can select the time frame here. So almost all of them are important, but you need to take a look on few of them to get an at least get an idea of what exactly happening. So as you can see, a wire tagger cache activity, basically means that how the wire tagger cache is being performed currently, whether it's serving requests directly from the cache, or it's basically reading out from the disk, or reading from the disk and writing back to the disk, right? So what type of operation your wire tagger currently is doing. And wire tagger block activities means that how much amount of data is being read from the cache directly. So no disk is involved here, and how much amount of data is currently writing back to the disk, right? Sessions here, how many sessions are being currently established, and the concurrency tickets available. This is also important. So if it drops at a point of 0 or even 1, it means that no tickets are available to serve your incoming request. Similarly, queued operations, wire tagger cache evictions. And this is also an important one. If you're seeing a lot of cache evictions, it basically means that you have starting building a lot of cache pressure, right? Means that your wire tagger cache is not sufficient to hold that much amount of data which you are querying, right? So it has to create some room, evict the least recently used pages, to at least hold the new pages that are coming back from Redis due to new queries, right? So this is the checkpoint time. If you are seeing a longer checkpoint time, this basically means that your disk is not performing as expected, because it's already utilized because of other operations. Similarly, here white tagger cache pages, it means that what type of pages you have. These are total pages, right? Because of already the cache is already warmed because of several query which I ran in the backend. And another legend is, you can see, is dirty pages. So basically the pages which are being modified into the cache because of write operation are yet to be written to the disk. So all those pages are currently lying inside the cache until the next checkpoint comes up and flushes them to the respective data files location. This is the cache activity which I was mentioning. So there is a certain soft level, soft and hard level in wire tagger cache uses. So the first is 80% overall cache utilization. So if it reaches, if it needs to grow beyond 80% of the maximum configured cache size, then it will start evicting least recently pages, right? If you can see here. So it start evicting a lot of recently pages to create some room for the new pages coming up. So all these metrics are basically will help you to identify the exact issue which is happening. Is this because of you're hitting the resources, or is it because your workload that are coming up is not optimized at all? So talking about the next topic we have is the sizing the cluster properly. This is the most important one because most of the times that I have noticed that uh, the cluster that you have deployed is not at all properly sized based on the requirement from the application, that the type of workload you have, the traffic we are expecting, right? So you need to think about all those things and size a cluster properly. And by size a cluster properly, I meant to say you have to have sufficient amount of resources available already ahead of the time, so that you can serve your workload in a better way. So as a part of sizing, the most important factor is the type of disk you are choosing. Obviously, the recommended is SSD. If you have the local SSDs available, that would be best. And the amount of IOPS that it can provide you, that also matters a lot. So for IOPS, you need to think about on an average point of time, how many operations per second or requests per second you are expecting, right? And how many connections as well. So let's say as a thumb of rule, on an average, I would say the number of IOPS needed per write operation is basically 1 plus the number of indexes being affected. So let's say in a particular collection, if you have 10 indexes and all of them are being affected for that single write operation, because all those relevant entries has to be updated in the binary tree structure of index, right? So it means that 1 plus 10 means for one write operation, you have to use 11 IOPS at the same time. So you can imagine if you have if you have write intensive workload of 1,000 queries per second, 1,000 insert, subdue, delete per second, whatever, you are going to use 1,000 multiplied by 11 IOPS, right? And apart from that, for remaining operations as well, like for checkpointing, for maintaining the connections, right, IOPS will also be needed. So you have to, you know, you have to deploy a cluster with a sufficient amount of IOPS, right? And same for the reads as well. It basically means like based on how much the documents you are returning per second, the significant amount of IOs being used for that as well. Those IOs will not be used if the query is direct. Queries results are directly fetched from the cache itself. If it's hitting the disk directly, then eventually it's going to use the IO. So that's same, right? Same like memory needed. Like how would you calculate the memory? This is also an important one. This is basically in memory scenarios, you need to think about how much is your working set, right? So on a rough note, working set is basically the amount of the active data set, the part of a data set which is active that you are frequently accessing is basically a part of your working set, right? So let's say you have 4 years of worth of data stored in a cluster, but eventually you're going to access around, let's say, a couple of months or maybe 1 month worth of data, right? And I'm assuming that all those are indexed properly so that you don't have to scan all those 4 years of worth of records. So now, if you know that you're going to access only 1 or 2 months from the current point of time, all those records at any given point of time, right? So what you can do, you can find out the rough amount of records and then get an idea, because you need to find out the average object type. Let's say in our case, I'm dealing with uh, records of worth a week, let's say 100 million, with average object size of 1 KB and 5 relevance indexes of 5 GB, right? So because indexes size, the relevant indexes size are also part of a working set. So that gives me around 100 GB of working set. Now, entire working set has to fit in the memory so that I can avoid any unnecessary involvement of disk, because this is already being used for other operations, right? So I don't want to serve any requests from the disk. I can directly serve from the cache itself, which is very much faster compared to disk. So for that, since the soft limit is 80%, I can safe to say that I should be having around 125 GB of wire cache configured, right? So at any given point of time, the entire working set can remain entirely in the wire cache. So accordingly, at least I should be having the server of at least 200 GB, right? To have the default cache configuration. Uh, I would say at least 200 hours written here, but that could be like 200 to 250 GB at least you should be having. And let me show you with an example by firing a query in the background so that you know how it behaves. So I am basically going to, let me give you a moment. I will just quickly. Okay, I'm going to fire a query, right, which is not indexed. So it will give you an idea. So but this first query is basically indexed. So I'm going to run it against the database and see how it behaves with the cache. Okay, so this is already run. I am sorry if I haven't shared my shell with you, but anyways, I'm running in the backend, so eventually it will show it up. Now I am going to execute a query, the similar kind of a query, but a different field, which is non-indexed. Let's say it's still running. The background will take a while. Now it executed. Okay, now you can see here what is going on 1 second graph. Let me just select last 5 minutes so you can see here. See, the first query was indexed, like I said. So you can see the internet transactions there was spiked up a lot to serve that query. Similarly here, as you can see here, it's saying read into from the disk is not significant because most of the query result set was served directly from the cache. Now here, if you can see, it has to read a lot of data, which basically tells you that it has to read a lot of records from the tickets directly because of the call scan operation, right? Since it doesn't have an index. Similarly here, it has to first bring the documents back to the cache, then serve the read operations. Right. Similarly here, if as you can see, there was no cache evictions for the index query, but for the non-index query, cache eviction has to happen of around 20 pages, right, per second, which means that your cache was already utilized. Now for the second query, which was non-index, the result set was not existing in the already warmed up cache. It has to go to fetch those records. Since the cache was already utilized 80%, it has to create some room and store. So while creating the room, it has to evict a lot of pages. That's why the spike you are seeing here, right? Remaining is not significant, which are not directly related to that. This one is quite important. As you can see, this is saying scanned. This basically means that you're serving directly from the index. However, this one is scanned object, which means you're not serving directly from the index. It has to serve it has to go to the disk to return those documents back to you. And as you can see, the spike here as well. And in the node summary, as you can see, the CPU is significantly low because the data set was not sufficient. I mean, to say the data is not large enough. It was around 1.5 million documents. So it should be normal in majority of the cases. So this is how a single query, just with a difference of an index, can put a lot of pressure onto your cache. So imagine if you are doing a lot of queries, similar queries concurrently on database, what could be the impact behind that? Now let me. Okay. So this is how the behavior of your behavior of your database if you not have sufficient amount of resources available, right? Which is part of example we have just seen. Now, next is indexing and the query patterns, which is yet another important way of optimizing your workload. So always use your indexes wisely. Wisely as means as always try to have as many component index available, because it's an opportunity to have least indexes available and improve your cardinality as well. Like if you have, because you're not directly running a query and looking for a certain document having this particular field value, right? You will be doing a lot of queries like find this document, sort in this way, and maybe doing a lot of aggregations. So that involves multiple fields. So always have a compound index that in a proper manner, that have created in proper manner, that we'll be going to discuss in the next point. So always use your indexes wisely, right? And follow the ESR thumb rule, which basically stands for equality, uh, sort and range, so that in your particular query, if you know, if you have multiple queries in your, if you have multiple fields in a query, create an index in such a way that all those fields which are doing equality in your query has to be in the beginning of the index, right? And then comes the sort part. So if a particular field is doing a sort in your query, put it after the equality, and at the end put it the range one. Okay, this is the thumb rule if you're creating a compound index to serve your queries. Other if not, then you will run out of a lot of in-memory sort, blocking sort issues eventually if you are not following the correct order, right? Analyze and get rid of unused and redundant indexes, which means that you need to, over the period of time, you need to look how your indexes are being utilized, and if there are redundant indexes exist, means duplicate indexes exist, get rid of them. But at the same time, make sure that you have sufficient amount of uptime available, and what type of application read logic has been applied. For example, let's say if you're taking a look into your primary, but your application is reading from the secondaries. So always make sure that you are taking a look on all those nodes at the same time and then coming to a conclusion. Why I'm saying that? Because for every write operation, for the read operation, having indexes is fine. But for the write operation, it comes as a trade-off, because for every write operations, all those relevant indexes has to be updated accordingly, right? That adds a lot of overhead for you. I will show you while firing a query in the backend so that you will get an idea how you can see the drop in the throughput. So this is the command you can run and look for the accesses.ops if it's equal to 0. And always make sure that you have sufficient amount of server uptime. It's not something like that you have restarted a server an hour ago. Obviously, there are high chances that you are seeing this particular document in your returned, this particular field return document in index side 0. So if you have sufficient amount of uptime, let's say over a month, something like this, then you can finally conclude that, okay, the index is not being used. So then go ahead and plan reducing, I mean, dropping them. Redundant indexes basically means that, let's say in our second case, these are basically very simple examples. So to give you an idea, let's say you have two indexes. The first one is single field, another is compound indexes. So if you can look closely, any query which are doing equality against a field will anyways be going to use the compound index, right, by the optimizer most of the time. So having a single field index on A uh, is kind of a wastage. It's duplicate if compared with that compound index exists. Had it been B and A, order had been different, it's not suffix, then you can have it. But in our case, you can just go ahead and remove such indexes, such single field indexes. And while aggregations always use match stage as early as possible ahead of all those stages, so that you can filter out those required and use the prefixes as an equality of any indexes existing in your collection, right? Avoid doing avoid using allowed disk use unless your stages in your pipeline gets hit with 100 MB certain limit of your memory, right? So avoid doing that, because disk is anyway slow as compared to memory. If anyways you have to use it, it might be that either your query is not optimized, or if you are dealing with large amount of data. For that, always optimize your workload. Use batches to do your all those operations. Write performance while doing heavy write, use bulk write in unordered manner, especially in sharded cluster. Why it is important? Because sharded clusters are distributed, right? So if you are doing order as false, always use bulk write first of all. And if you're using bulk write, always use order false, especially in sharded clusters, so that you know your writes are not at all be used in a sequential manner. They can parallelly execute in all those shards, since it's a since because of distributed nature of sharded cluster, to get a better performance out of it. Write concern similarly, as much as possible, reduce the levels of write concern to get the most performant out of database, because anyways that's how write concern works internally. It has to wait for the acknowledgement for all the secondaries. That creates a lot of latencies if you have slow networks or maybe slow response in secondary at the same time. So as it's obvious that for the data integrity purposes, that not always be optimal for your business logic, but at all possible, reduce the write concern levels. Next is workload distribution and scaling. This is also important, like how you can scale your workload, how you can distribute your workload. So the first is replica site configuration. Whenever possible, use secondaries for the reads and offload a primary. If your business logic allows to read a bit of stale data at a certain point of time, that is fine. So use secondary preferred, not always secondary. So this is how you can overcome a bit of workload from the primary. Next is write concern that I have mentioned just before. Always keep same resource, so the cluster nodes. This is also important. I've seen a lot of scenarios wherein the clusters are misconfigured in such a way that few of the nodes are not having the same amount of resources. What then happens if a failover happens? If they will become primary, then entirely your throughput will reduce, right? You cannot serve similar traffic at the same time. It can be avoided by there are certain cases where you can have them in a low priority so that they cannot become primary. But if you don't have, you have default voting and default primary is still having less resources compared to other nodes, this is not good to have. So always have same resources. Uh, for the backup nodes as well, if you have dedicated backup node, I don't think that you can have less amount of resources and get ahead of that, because anyways, for the backups, it has some overhead as well. That's for another talk. Adding more resources, vertical scaling. So resources you can add in a couple of manner, which is your vertical and horizontal scaling. So for vertical scaling, you can introduce, like you are topping up your database nodes, bringing more memory, bringing more CPU, better disk, right? That is going to help you for a certain point of time until that single, because in a replica set only one node is responsible to serve the right replica. But until you reach that point wherein you feel that adding more resources is not helping you, definitely you have to have to introduce a sharding in the database. So if you're not aware of sharding, it's basically distributing your entire working set into different piece of machines, right? So all those machines hold a portion of your data at the same time, right? So, and if you are implementing sharding, there are certain points you need to consider, such as if you are choosing a shard key in order to distribute data, choose it wisely. Wisely as in it will help you to evenly distribute your data, evenly distribute a workload. For example, it has to be high cardinality so that you can evenly distribute your data across all the shards which you have. You cannot have hot shards one at a time that would end up serving all the workload because of the bad shard key. You cannot have that, right? Same as the frequency, how much frequent your queries involve the shard key, that also contributes a lot. And if you're creating a shard key, always try to have a compound shard key for the same way where we are creating the compound indexes as well. In order to increase your cardinality overall for that particular shard key that you are creating. Now, based on your workload, based on your business requirement, you can have different kind of a sharding, range sharding, hash sharding, and zone sharding, right? So just try to identify the workload and the business requirement. Based on that only, create these type of a sharding, right? Always include shard key in a query so that you can improve the workload in a better manner, so that whatever the piece of data you are trying to fetch should not be scatter gather here, right? It can directly go ahead and hit that particular shard where the exact data is located, and you can get directly from there, right? Create compound shard key, which I mentioned earlier. And this is a bit of important one, the balancer window and chunks distribution. So let's say if you are very busy traffic most of the time of the day, and in the night, let's say there is significant drop in the traffic. So what you can do, you can enable your balancer window at that point of time, so that all those balancing operation can happen during that time, which can reduce, which can help you to reduce additional overhead which might have created for the remaining time of the day while doing all sort of balancing works. But there is a certain trade-off, because let's say if you have very high redundancy workload and that particular amount of window is not sufficient enough for you, then you will end up with the same issue. So try to find out that point of time where you can significantly define a balancer window. Next is chunks distribution. So as we all know that how the balancer works is basically until the certain migration thresholds, all the chunks are being equally distributed across all those shards which you have in your sharded cluster. But in a certain cases, let's say if you are running a large set of purging of your records, that might have resulted in deleting majority portion of the data from specific shards. Remaining shards were kind of ineffective, right? So what then happened, those chunks will still be there, but portion of the data will be removed because of purging activity. Now the balancer sees that the number of chunks remains the same, but in reality, the amount of data is now located onto the chart is less compared to where the purge didn't happen at all, right? So always try to do some kind of a calculation based on that and try to split the chunks in such a way that you will get an end result of equal amount of data distribution across all the charts, right? So the next is tuning the workload, basically tuning your queries, how you can tune them. So now how are you going to find them? Because you cannot get everything in the logs or in the profiler. So you have to compile everything and get all those queries which are offending in your database. So look for the logs, look for the explain in the profiler. You can directly get the all those entries which with all those operations which are executed slowly, right? So look for all those stages in execution steps. Avoid call scan and in memory sort like sort key generator, sort merge. All those execution stages has to be avoided at all because they will add an overhead for resources. So most of the time it has to be, or almost all of the time it has to be IX scan, right? Based on that, you can optimize your query. And the ratio of total keys examined or total document examined has not be more than one almost every time. And if it's always good if you can have total documents examined zero and the number of written and total keys examined are equal, which means that your query is now covered. Covered basically means the entire query return the results directly from the indexes instead of fetching remaining fields from the disk, right? So always follow ESR approach. Like I said, always keep equality in the beginning of compound index followed by sort and range. Like for this particular query, this particular index will work. If you can see on QScene, I was doing equality, so I can keep QScene at the beginning of the index, then stars because I'm doing this sorting on the stars, right? And then at the last, I can do address or zip code because it's a range query, right? So when the query will fire, the optimize will directly go to top of the binary tree of the index, look for the QSIN. Based on that, stars will already be sorted, and then remaining address or zip code will be returned back to you. Avoid unwanted arrays. This basically means that I mentioned earlier as well. If you have large arrays in your documents, what happens for every update operations, those temporarily those arrays has to be stored as a document until that update operation succeeds with the new added values in that. Regex operations as well, like if you have created an index on a string field and then you are running regular expression. So what happens, that index will only helpful for you if you are using a wildcard, so that beginning of the the prefix of those string are matching, so that based on that it can identify the relevant document. But if you're using a wildcard in the middle of the string or at the end of the string, the index will not be helpful for you. So there are certain ways to improve that as well, so keep in mind that. Okay, this is all about from my session. If you have any questions, you can directly reach out to forums.percona.com, or you can directly DM me into the below addresses of my profile. Okay, I'll stop sharing my screen. Happy to have you all in the session. I hope to see you in the next one. Bye-bye.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Welcome everybody in Percona Live. So today's topic is PostgreSQL and artificial intelligence. So my name is Ibrar Ahmed. So we will talk about some of the artificial intelligence, and initially was artificial intelligence, then we think about integrating that with PostgreSQL and the database. So who am I? I have been in software since 1998 and I have 16 years of PostgreSQL experience. So I have multiple books and my social media accounts are here. So artificial intelligence. So I will discuss about the what is the artificial intelligence in some slides, and then we'll go to the other part of that is machine learning, deep learning, and have on a demonstration, and then we will discuss about the why we need a database to have a machine learning and artificial intelligence, how we can use a database to apply some of the artificial intelligence algorithms and something like that. So artificial intelligence. So the machine that mimic the conjunctive function that's human associate with the human mind, such as learning and problem solving. So we are thinking from our mind. So we want to computer, a machine, to learn like a human brain, to act some action, to perform some action. So as a child, he start learning from his childhood, and his brain is trained to do some activities. So we are performing the same activity to the computer to feed the computer the information, and that computer is start learning from that information and from that learning, and then it can decide and it can take action over that, similar to the human brain. So artificial intelligence is no match for the neutral stupidity. It's Albert Einstein, and then a machine with AI is able to think and act like a human. It is able to learn from experience. So, and from the Einstein, I think the development of full artificial intelligence could spell the end of the human race. So it's a mixed kind of attitude from the different leaders. So the one who become the leader in this sphere will be the ruler of the world. So it was just a quote. So now we are going to the real artificial intelligence. So there are three types of artificial intelligence. So when thinking about, there are, first is called ANI, artificial narrow intelligence. So what is the narrow intelligence? In narrow intelligence, if a computer can perform a single task, so we will train the computer to perform a single task. It is much less than the human. Human can perform many tasks, but if a computer can perform a single task, something like Siri, the Google and something like that, so it has a simple task, a single task, that we trained it, it will perform a Siri and something like Google Ads, suggest us something that, but it's not acting, it's not performing a multitasks at one go. So then in the middle is AGI, artificial general intelligence. Artificial general intelligence is like a human, because human is trained to do a multiple task. So it learn from the environment, it learn from everything, from the data, everything it has in mind. So it start performing the action. So it's comparable to the human. So the previous one, the ANI, artificial narrow intelligence, is less than the human, but the AGI is around almost the same. The human can act on that, the multiple tasks. So ASI is artificial super intelligence. When we are talking about the artificial super intelligence, that means it can go beyond the human, because human can learn and act accordingly. but human does not accumulate large amount of data. Like if a computer has a capability of human mind and it has a huge amount of data and it start learning from data too, that it can act beyond the human. So that's called, but we are not achieved, which system is not capable of doing right now, but the artificial intelligence are working to do that. It's dangerous, but it's beneficiary and it's dangerous too, because a human has a limited capacity of storage of data. Like it cannot remember that it's a bank transaction, how many bank transactions are in the bank, it cannot remember. But if it has a capability, a computer has a capability of human mind and have a data of all the bank accounts detail, so it can act much more than that. So it's called artificial superintelligence. So ASI is a more capable than human, learning from past experience and from new data to be a variety of tasks. So that was the type of artificial intelligence. So then there are subfields of artificial intelligence. So it's artificial intelligence is a word, but it has subfields. So in which field you are working on that? The first one is the machine learning. So you feed the information to the machine and machine will learn from that and then it will act accordingly. So it's similar. A child when is born and is grow up, you are teaching him to learn the language. You are speaking with him and start accumulating the data inside, and they will start acting and start speaking using that. So similar, the machine, you will feed the data into the machine and then that machine will act from its past experience, from its learning. It's the machine learning. And deep learning is a bit of neural network. So it's a bigger neural network. So we will discuss it, what is the neural network and what is the deep learning next slide. So conjunctive computing, that it's also from the learning, so it's start learning, and then other field is natural language processing and computer vision. So artificial intelligence. So we will gather the data in first stage, then we just perform some cleaning stuff over that we clean, prepare and manipulate the data somehow. So have a clean input for our machine. So then we train our data. We train our model on that data. Then we have some test data. So we will test that, so how good our model is trained, and then we improve. So this is a cycle. So you gather the data, you have a bunch of data, then you clean it up, then you train your model, then you test your data and then you improve. So you keep going with this cycle. So ultimately you have a good model where you put some unknown data, so it will give you the proper result. So we'll see with example. So machine learning. So machine learning is a concept where you input your data and it will learn from data and it will act accordingly. There are three types of machine learning. One is the supervised learning, and other is the unsupervised learning, and then reinforcement learning. What is the supervised learning? In supervised learning, we have a data and we have a labeled data. Labeled data means we have data and we also have a result of that. Okay. So when we have a result, we trained our model on the data according to the result. So when we train the data, so data is correct. So like we have some kind of a data that we in a database and the result is true, and other row result is false. So we already know the result is true or false. So we will train our data that this data produce true or false. It can be any value, it will be in numerical value and something value. So we trained our data. So when we see that this row will produce true result and this row produce false result. So we keep putting this data into the model, then where model is trained that this kind of a data always produce true and this kind of a data always produce false. So, in that case, when you give that to unknown data and which will match the false or true, it will produce true or false properly, because it will train from its data and its output, that you have a result also. Like if you can say that you learn in a college, you study different subjects. So, you have a different marks, you are pass or fail, you are pass or fail. So, it will learn from data, you are pass. So, it will learn from data, you are fail. So, to continuously putting this information, because you have a query and you have a result, you have a data parameters and you have a result, you continuously train your data. And when you put unknown data where you do not have a pass or fail, something like that, it produces the actual result. There are chances of error there, but that is the way we train. And where it is we use it for the clustering. If you want to do some kind of a clustering of data, that's this data is this, like this is, we can have an example like this is a chair, this is the four legs and a top. These are the two properties of data. This is the four legs and one top. This is the property, and we have a table. Resulted table property is four legs and a top. And for the chair, we have four legs, one top and one back. So, we have a properties here. So, it is a chair. So, we are continuously putting this information, a different information into that. So, whenever we put some kind of this information into the database, it will produce is a table or a chair. So, we will put every kind of a data where we already have a result of that. That is called a supervised learning. It is similar to the child. When the child, you trained your child, that you said that this structure is a table. So, the child will remember this is a table, and you said this is a chair, the child will remember this is a chair. So, when you ask what is this, he will say this is a table, this is a chair, because you are supervising him in that case. So, regression and the clustering is the main objective of that. And unsupervised learning. In unsupervised learning, you have a data, but you do not have a label. You do not have a label. Like you know that this has the property, but you do not know what is this and what it produces. So, you put this kind of a data and you get the result. So, how you get the result? Most people are confused. If you do not know the result of that, how you can produce that? It is used for the association. Like if you go to some mart, you buy bread, right? And then you buy eggs, then you buy milk. So, it will create an association between bread, eggs and milk. So, whenever a person buy a bread, he usually buy milk, he usually buy eggs, and somebody buy a meat, he has some spices. So, it will create an association between the objects. So, we do not know what is this, we know this is something, it is egg, we do not know it is egg something. So, what is the benefit of that? So, when we try to learn from this, we make the association. That is why the grocery store usually put the bread, the egg, the milk in one side. So, whenever somebody grabs a milk, he will definitely grab bread. It is not 100%, but it will create an association. So, in a mart you have a different sections. So, it will attract the people. So, like if you do not have an association, you have a milk there, you have a bread there. So, usually somebody have a milk and he will go out, but he will say milk, oh I need bread. So, you just pick the bread there and you will get out. So, this is the marketing strategy. How it is learned? It is a unsupervised learning. We are not supervising, we are just learning from the data. The machine is learning from the data that persons are buying similar kind of things, and what is the thing? So, just put that things in that area. So, this is called the reinforcement, unsupervised learning. So, we are not supervising, we are not telling what is this, but previously in supervised we are labeling the data, that this data is this data has a this property, this data has a this property and this result. That is a label. Unsupervised, there is no label on that. Then the reinforcement learning, and the reinforcement learning, you have you can say that is a hit and trial. Like you are going somewhere, like you are going from here and you see there is a wall, you come back, you go to set, there is a wall, you come back, there is a wall, and you come here, there is a wall, you go there, there is a door. So when it's try to learn from this, so next time he wants to know where is the door, he knows there is a door, and that side there is door. We don't want to go the left, don't want to go right, back, front, so it is sideways, there is a door. So it will learn. This is the basic of robotics. So usually you see the child's cars, they usually go and just stop because there is a wall there, just stop there, stop there. But it's only a data. If there is a machine learning algorithm, next time they will not go and touch the wall, they will go direct to the door, because they don't have an algorithm. They only have a data, but they have no algorithm there. So this is the basics of the robotics. So these are types of machine learning. And the deep learning is a neural network with more layers and modules. It has a model which can take any input output type of the size. In this case, this is the neural network example. So I will go, and next slide is deep learning is a neural network, because neural network and deep learning almost the same thing. Is the base is the neural network, and the deep learning has a more layer, something like that. So you, in this case, you don't have some kind of a properties of thing. Like I said that there is a 4 legs and top and this. So you need to, you are providing this information to the machine learning, that this has a top, this is a 4 legs, something. But in neural network, you have to extract that information too. Something like you have 3 input here, and these are the input node layer, and then the hidden layers, and then the output. So it will input, it's like a human neuron, the brain has a neuron. So how the neurons act like. So we input the data, and they calculate the weight and everything, and that put the resultant value to the hidden layer, and hidden layer to the next hidden layer. So next hidden layer, because here is the only one hidden layer, but it can be the multiple layers here. So ultimately, if it's close to the output 1 or close to the output 2. So I will give the example here that if you have recognized 1 to 10 number, 1 to 9, it's a 0 to 9, sorry, it's a 0, 1, 2, 3, 4, 5, 9. So that means you have a number, and you have to recognize it is a 0, it is a 1, it is a 2, it is a 3, what it is. So when you input the data 1, in a hidden layer, it will cut down the portion of your number. 1, suppose we are only 2 layers, so we are cutting down the number in 2 shapes. Like 1, we cut it the half 1, half 1. So we pass that information to the next layer, and next layer will decide that if you have a 2 stick, so it's a 1. So if you have a 2, so we divide that 2. We have a 2. I don't have on a board here. I will explain that. You have a 2, so we cut in between. So half portion this or half portion this. So in the next layer, we will decide this is a 2. So if we have another layer, so we will cut 2 half portion again. This is 4 parts. So that this and these properties it had, it is a 2. So something like that, when we train that, the neural network will run continuously running, and we have a model ready. So whenever you put 2, it ultimately said it is a 2, and said 3, it will say it is a 3. So we trained continuously. So it has a many algorithms in between the back propagation, in back propagation and forward feed. So I'm not discussing all of these, because there are a lot of stuff in the neural network and deep learning. Because in back propagation, you are getting the result. If the result is not correct, so you just come back to the input, then again change the weights, and you can get the data again. So you continuously doing that. So ultimately, you get the final result. So you trained your model, then when you put unknown data, it will extract. So what is the difference between the machine learning and the deep learning? You know that why we 1, 2, 3 we put it that we have not provided any information there. What is this? But in the machine learning, we said that it is a 4 legs, top, everything, we are providing this. But in this case, we are extracting the feature of the thing within the model. It is part of the model to extract the feature of the input and then produce the result. So, here is the as a deep learning. So, you can see there are multiple layers, multiple models are here. So, you can see that here there are pictures of persons, right, of many persons. So, you want to recognize who is he or who is she. So, in first pattern we just grade scale that every information, and you see that there is the eyebrow, there is something like this. So, we extract the information from these pictures. This is not one input, it is the multiple inputs. So, when you put one picture, so it will compare that who has this kind of eyebrow, eyes. So, it then divided that into lips, nose, it start cutting the portion and said that a person has a wide nose, a thin eyebrows and long hair is this one. It will start deciding, but it will not say that the output is this. So, you can see ultimately you have the face of that, and the output layer it will recognize that this person is this. If you put the picture, it said this person is this. So, it extracting the properties of input. In machine learning we are providing that, but the deep learning or neural network it is extracting the information from the input and then generating the model, and when you feed the unknown data it will produce the proper result. So, here is another example, the machine learning. You input, you extract the feature, it is a human is extracting the feature, not the machine. Then you do some classification, classification or whatever you want from the machine learning. So, car, not a car. So, you provide it has a 4 wheels, it has a body, it has a steering. So, you are providing this information. So, he said it is a car or not. So, he said it is a 2 wheel. So, it is not a car, he said it is not a car, but if you provide 4 wheel it is a car. So, you are providing the information, but in a deep learning you input the car only and it will say it is a car or not, yes or no. It will extract the feature from the input and then classify it and said it is a car or not a car. So, we are not providing any information there. So, here is actually is from the Bruce talk. So, he has provided the talk some months ago. So, I have got the courage to ask him to give me the example from this. So, I got it from him. So, it is from, so I have to give the credit that he wrote this example, because this is a basic simple example. So, you have a number, and you want to look at that this number has a 0 or not. For looking at that, you can see, oh, first one is true, it has a 0, and second one is false, because of the human mind. The human is detecting that there is a 0 or not. So, the other way is mathematics. You can perform some mathematics and you can get this as 0 or not, right. You can do a string processing and you can see there is a 0 or not, but we are not going in that detail, because a simple example there are other ways, but in some cases you do not have on a mathematical solution, you need to learn from that data. So, here multiple solutions available, but we will perform artificial intelligence to detect it has a 0 or not. So, say you can download the complete example from Bruce website. So, it is all the examples are there. So, you will get the slides. So, I also provide the link of slides. So, from slides you can get this information. So, the complete example you can run it yourself. So, there are two things. One thing is that PostgreSQL have different languages too, like PL Python and PL Perl, and PL Python is really good, not PL Python, Python is really good for the artificial intelligence and machine learning. They have bundle of APIs available to perform the artificial intelligence. So, it is good thing that you can do it in Python, but in Python if you do that, you have on some API, you just put dot artificial intelligence neural network, it will produce the result. So, you can't see what is going on behind that. So, that is why I am happy that he has provided the Perl example, where it himself perform some tasks without using the APIs. Otherwise, API is just one two functions: input data, generate model, test data, and that's it. So it's 3 lines here. So there is nothing new for you to learn here. But he did that using the PL Perl. So a tensor is a data structure which can hold, actually tensor is a word used here to store the vector and the values, the scalar, the way to store the data. So we usually call in artificial intelligence it's a tensor. So we will generate a tensor. So I am literally not going into the detail of PL Perl. This is the example for you to try. I will explain overview of that. So you turn the, because it's quite a complex Perl things are here, but it's really good to you try it and run it, and it will generate the result. So we generate the data structure for that, and let me show you the I have the data of that. I think no, this is not data. So what we are generating, wait for the tensor node. Yes, this is the in the next slides. Okay. So we generate a tensor, we generate a data structure for that which can hold the values, like values is 1, 2, 3, 4, 5, any value it can hold, and it can set true or false, true or false. Okay. So like 1, 2, 3 false, there is no 0, 1, 2, 3, 0, 4 true. So it can hold this kind of a data, it's called a tensor. So we will create tensor. It's you can do a simple creating a structure there, so it doesn't matter. So but they are calling it a tensor, so we are also calling it a tensor. So I told you that there are some processes to do some machine learning, like we will train our data, right. So we need a training set, like we have 100 inputs, like 100 inputs, like 1, 2, 3 or 100 inputs. We know that we have 100 inputs. So from a portion of that, like 70%, 80%, we give that to a training set, like 80 values we will get to our training set. So we will generate a training set, because we are generating ourselves. So because we should have some data. So we have 80% of our data as a training set. So what is the training set? Training set will be 1, 2, 3 false, 1, 2, 3, 0, 4 true, 1, 0 true, 2, 4 false. So we have this kind of a data 80%. We have 100% of data, but we only extract the 80% of data randomly from there. So then we are generating the random integer. So we have a different values, not 1, 2, 3, 4, 5. So that's true. So here is the input. So we have a training output. So like you can see that there is a value and true, false, true, false, true, false, and the true and training set. I am just limited to 10. So we have a data, and then on data we training data, and then we need to test data. So we have a data. So we 80% we give that to the training data, and 20% give to the test. So model will be trained on 80% of the data, and 20% of the data will be used to test our model. So when this 100% is done, then our model is ready. According to that 20% test, how percentage accuracy it has. So we have 80% of data used for the training, 20% of our data for the test, because in 20% we will not provide true or false. We will not provide the result. We will provide only the numbers, and it will say it's true, false, true, false. So we will compare it to the actual data, and we will get the error, how much error it has. So here we are we need to generate some weights for that. So generate weighting and neurons. So like an example here, in this if you see that every neuron, so when passing to the other layer, it will be multiplied with the weight. Initially, it can be any weight, 1, 2, 3, any weight. So, you can provide that. But when this model is getting trained, we are keep changing our weights there to get the perfect result. So, ultimately we will get the final weight of that. So, that is because it will be really long if I just giving the mathematical example to differential, we create the calculate the differential, how we calculate the error function and then weight subtract the minus subtract the weight from them. So, it will be very long. So, training set is an input layer, weight we have generated the weight, we generated the weight for the multiplication, and that you can look at that in detail. For tensor mask and some weight, I just want to show up you the result. So, we need to store the results also separately. We need for the training set we are storing the data and the result same, but for the testing model we need only the data and the results. So, we are storing separately, because we will in that testing model we will not provide the results. So, we will have a separate results for that, and then we will calculate that result with the generated result from the model. So, we will compare that and we will see that how much error we have in our model. So, here is some tensor weight true or false. So, you get that in which you have a false or you have a true in the table. So, we are testing 100. So, you can see that the result is 0.077806133. The result is not really good, because it says it has a 0, it says is a 0.22%, or you can percent or 1 you can multiply by 100, the 22% chances there is a 0. So, our model is not really well trained. Its case said 77%, it has a 20 and still says it is a 22% chance there is a 0, and 77% chance there is a no 0. So, that means our model is not very well trained, because we have provided only the 100 values or 20 values or 30 values. It cannot be trained with this kind of value. If you have a 1 billion records, so you provided that records, how big your data is, that's accurate your results. So, like if you give some 4 or 5 words to your child and you are expecting him to speak English or some language, it is not possible. You have to give him enough data to speak one language. So, that is a similar, we are providing a very small data set and we are expecting that it will produce the right result. No, but it is an example. So, if you give them the more data, it will start you getting the proper result. So, you are getting a 0.22% will be increased gradually. So, when we will put a threshold that is even 80% or 90% true, that means our model is 90% accurate. Now, our model is 22% accurate, which is not good, but we provide more data, then it will be changed itself. So, you do not need to change your model will be the same. The important information is the data, you provide the data. So, these algorithm I just showed you, it is just in Python you have one function or two function, input, generate model, output, test, train, that is it. But here you can find the example here. So, you do not need to change your model. So, here we have testing the 101. In 101 we have only 10. So, you can see accuracy is again 0.11%, 11%. So, and another decrease in the accuracy. The previous one we have a 20, I said it look like we have a 0 there, because there was a 20, but here we have a 10, so accuracy is also decreased. That means we do not have enough data. So, look at this, we have almost the same result we are getting continuously, that this value 487234987, does it have a 0? It says 68% chances there is a 0. It is quite funny, because where there is 0 it is reverse. That means our model is not accurately trained. We do not have enough data to train our model to get the perfect result. So, you are keep getting training your data, keep training your data, you get, if you get the 90%, 80% or whatever your requirement, you will get the proper result then. So, then I have a test set. So, now we are generating some random number and then generate the series and start putting that into the testing for the 1000 value to see what is the accuracy we are getting here. So, that table expression. So, here you can see that the check value 6, it has many numbers. So, I am not 1000. So, I just have a 8 to 9 here. So, 6 is a false. So, 6 is the data and f is the over its false or true, it is a result. So, in output layer we are getting 029 and 097, the accuracy 8.47. Accuracy is 0.47. So, similarly, we have all the data here on the left side, we have the actual result. We have not fed it this result, the CMP bool we have not provided to the system. We know that this is there, but it will calculate. So, you can see the accuracy. Accuracy is not really good, but somehow it is good, somehow it is not good. That means, how much well trained your data is, you will get the accuracy much better in numbers. So, I am not here to produce the best number here, it is just an example. So, it can be the worst number, that means your model is not trained. Trained it more, so you will get a better accuracy number here. So, from the demonstration we have seen that we can involve database to get the machine learning or artificial algorithm to running. So, what people are doing actually? Machine learning, artificial intelligence or this required a lot of data, because in this example we have seen that we have only 100 or 200 values from where we are producing the result. So, lot of data. What actually the machine learning people are doing, what they are doing, they are exporting the data into the CSV file, because they have a separate library for the machine learning. They are putting the VACA or something Python library, they are putting in CSV file there and then generating the data results. So, why? We already have a data in our database. Why are you exporting that data into the CSV and then putting in the library? So, the main purpose of this, you use this data which is inside the database to produce the machine the results artificial using the artificial intelligence. This is the one thing, to use actual user data to produce the result without exporting to the external tools. The second benefit of that, to using database, you can use the artificial algorithm to have a performance benefit from the database. Like for example, you can have a data, you can have a statistics, you have everything. You can perform the machine learning algorithm on that data to produce the better results. So, similarly, I was researching on that. So, I will also discuss with Jim that transaction wraparound. So, usually it happens transaction wraparound thing. So, people do not know when it happens. So, I am writing a research paper on the machine learning that we will learn from the data continuously to predict forecast when this transaction wraparound will occur. So, like it will put a graph that it will, if you have a 1 year of data, is continuous reading that 1 year, 2 days and 10 seconds, it predicts that it will wrap around. So, be careful about that, maybe next week. So, we already have this kind of a data in a database. So, one purpose for the user data. So, user data do not export to the CSV file and get the machine learning algorithm work, do that within the database. The second thing, use the machine learning or artificial algorithm for the database performance and prediction or something. So, use the previous activity as a training data, like you have 10 years of data in your database. So, use it as a training. So, train your data for last 10 years and for 1 year just look at the test your model. So, you have plenty of data, 10 years behind you have a training data, or 1 year you are testing data. So, you can get the very good accuracy, so you can predict the next value. So, if you want to do that using exporting, so you need to export the 10-year data into the CSV file, go to the Python library, just input that, get the result, put the result back. So, after 1 month you need to do that again, extract that again, but you can continuously do that. And again take immediate action, like if you are not exporting that, you can take the immediate action if something happen, like commit transaction only if likely not fraudulent. So, you detect, you have an algorithm built into your database which will detect that this transaction is fraudulent or not fraudulent. So, on previous record that you have a record of 10 years that this activity looks suspicious, do not commit that right away, but if it does not look suspicious, commit it. So, otherwise exporting the data to the CSV, you can't do that, but if you are within the data, you continuously your model is training, continuously training your model. So, you keep updating your fraudulent information model there. So, it will detect is a fraudulent or is a not fraudulent. AI can benefit from database transaction, concurrency, backup. So, you are taking the backup, everything, because it is all about the data. Why we are not storing the data into the database? Machine learning required data in database should be in the database. Other benefits includes complex data type, full text search. So, everything we already have that. So, we can benefit from that. Postgres can do a GPU based computation inside the database. So, there is another talk is available from Boost that it has some slides about the GPU, how to use that. So, you can benefit that. So, here link is here in the bottom of that. So, how much time we have? So we have a user application. We discussed that we benefit of that, but the user application performance adjustment in database we can do some performance adjustment with your database. Optimizer plan, because we have a statistics. We have a statistics performance lost many years, maybe a lot of data is there. So, you can do optimizer plan, you can optimize that. Index creation and destruction. Database settings. So, what is database setting? Like you set the shared buffer, example shared buffer, and you are continuously performing some machine learning algorithm that you required more or less. It will predict for you that you required more shared buffer or less. So, you tune your configuration settings based on that algorithm. Then resource usage, you continuously monitor your resources. So, it said that this is this peak time, that usually you have a peak time on a Friday night and you do not have any peak time on the weekends. So, it will also predict the days and something like that, where the resource is mostly used and which days, at what time. So, you can manage your resources. Alerting, definitely malicious activity, fraudulent activity. You have a model, because everything is model. When you train your model to detect the malicious activity, so whenever some malicious activity come, it will say, okay, stop it, it is a malicious activity. So, you can alert that resource exhaustion, like it can also predict that when your disk will full. So, it will alarm you. So, just alarm that is going to be full in next week, 1 month, something like that. Not amount of MBs. It is possible you have 100 MB left, but you are not doing anything. So, 100 MB is enough, but you have a 10 GB left, but your the system detector it will be expire in next month, it full in 1 month. So, you have to add more, or you just clean up your previous data. That is everything time. So, question. Yeah. All talks are available here on GitHub page. All talks are available here. So, these talks, the Austin one is available on GitHub page. Just you go and download there. And for the examples, even example are also pasted here, but if you actually go to the Bruce, I also put the link of that, the Bruce site, so you can download the code from there, but code is also in the presentation. So, we're good? Yep. Thank you, everybody.
Okay, hello everyone. Welcome to this talk of Percona Live Online, the low-hanging fruits of MySQL. My name is Kedar Vaijnapurkar. I am presently working at Percona as a MySQL DBA in Tier 2 team. I have like 15 years of experience. I live in Vadodara, India. I'm one of the eventual DBA who turned into MySQL from the programming background. I enjoy spending time with family. There is a little picture of ours. I also like listening to music, taking photos, playing chess, cricket, and also blogging. Okay, let's quickly move to the agenda. what are we going to do today? We are going to understand the low hanging fruits. What is it, how low that is, and what is beneficial, how it is beneficial to us. Then we will talk about the things we should consider before we decide to pluck the low hanging fruits. And while we will identify the low hanging fruits in MySQL, we'll look to get the quick tips about them and fixtures that I usually go about it. Uh, and towards that, we'll have some conclusions to make. So, low hanging fruits. What are they? The common understanding of low hanging fruit term is something that is easily achieved with minimal efforts and possibly low risk. This talk about the low hanging fruits of MySQL aims to point you towards the important aspects of the database improvements that are into common knowledge, which are proven to work in most cases, and some of the basic things that you should check, or something that I usually check when I'm going to I'm looking about improving the database performances. Um, Moving ahead, before plucking. So what is something that we should definitely consider before implementing or before deciding on the things that we are going to talk in this talk? So to start with an example, that we all know that disabling binary logging saves up some space, right? It will save some space and save some additional IO that requires. So should we do that in all the environment that we have? So this is not. So this is something that is a low-hanging fruit, where disabling binary log will save up some space and IO, but that is not really identical or say ideal for all the environments. Like for example, if we need your replica to be a candidate master, then disabling binary logging is not a good idea there. If we have idea of having additional replica underneath those particular slaves that are there, then also that's not a good idea to disable the binary logging. So like we have a solution here, but the very ambiguous answer in the consulting world is it depends, right? As annoying as it may sound, it is true. If something works for client X, it is not guaranteed solution for problem the same problem in client Y, right? So before using any trick in production, DBA should weigh in well with respect to their environment. They should test it and then go ahead and look if they want to that is a good fit or not. Nothing is low unless you know. Even though I name this talk as a low hanging fruit, I'm not saying that it's going to be easy. It's not going to be solving all your problems. The points we discuss here are surely of very important, and something that I do check during the usual reviews of the environment that we have. But production is not for trial and error. So take the points that we discuss here as a guideline, test them well, and follow it on. All right, so identifying the low-hanging fruits. Where are we going to find them? We'll start from the configurations, system and database level, where we are hosting the MySQL server. We'll talk about the database design, executing the queries, indexing strategies, or some of the tips about indexing, and we also talk about replication. We'll also look at the few points on backups. We'll look at the Swiss Army knife kind of tools that we database consultants keep handy. And finally, we will have a few points on the cloud environment that we should keep in mind. Note that we have included the links for additional information in these slides. We are not going to discuss everything in depth because we are covering a lot of points here. So if you need to go and dig deeper in that particular points, I have links included. Please go ahead and explore them. Do not hesitate to reach out to me for any further explanation. Okay, let's start with MySQL configuration, the famous myr.cnf file. If you ask the single most powerful variable to tune in your database environment, it will be InnoDB buffer pool size. What is InnoDB buffer pool size? It is the memory space holding the in-memory data structures of InnoDB, like buffers, caches, indexes, um, raw data. So Ideally, we allocate 75 to 80% of system memory to the dedicated database server, right? Uh, Consider the word dedicated. If database instance is sharing the server with the application or something else, be careful while you're allocating the memory. Next one is actually related to the related variable, which is inodb buffer pool instances. What it does is it mentions the number of instances or say chunks of the buffer pool that we are going to make. So buffer pool access also takes a mutex, and if we have high concurrency, sometimes this can become a bottleneck. Like every every connection is trying to access buffer pool. So documenters suggest that we have up to one buffer pool chunk of at least 1 GB in size, uh, but um, you need to verify whether whatever configuration you are having right now is really causing any kind of contention. How are you going to do that? Well, the engine RDB status, you should look for the mutex around buff or buff.c, and if you're looking that if that is something that you can take as a hint that your buffer pool instances are not sufficient, so you can consider increasing them. There's a link associated here with the refer word. You can click on that and go ahead and explore the details that are there. Next is INRB flush method. This variable defines the way we open the database files and logs. Most common method or say option that works for us is odirect. Odirect is a flag that is passed when a file is opened. It instructs to bypass the page cache and perform any IO operation directly against the storage. It is not going through the page cache or kernel scheduling for write back operation on the disk, etc. uh, go ahead and refer to the link for details there. InnoDB. So the suggestion here was like use odirect for InnoDB flush method. InnoDB log file size. This variable defines the read or log size. The read or logs are the disk-based data structures that are used during the crash recovery to correct the data written by incomplete transaction that are because incomplete transaction that caused by the crashes. Now, InnoDB flushes the modified data pages, which are there in the buffer pool, to disk in a small batches. And this process is known as checkpointing. The logs by default are by default they are two logs, and they are circular in fashion, like they are written circular in fashion. So one log completes it flushes that and then start writing on the second one. So the checkpointing is done when every time these logs are rotated. So the log one is rotated, the checkpointing is pressed for writing those contents to the disk while the other log is getting filled. So if the log is small, the checkpointing is pressed to write that logs to the disk really fast. Uh, if we have a larger amount, larger size allocated to the InnoDB log file size is going to improve the performance. Now there are conflict information in the documentation, if we might have read that making the reader log larger will cause the log recovery slower. But then there is another information that says that there has been improved uh, code for the log recovery section, where you can make the log InnoDB reader log large enough the way you want, even as large as the buffer pool size, and it will not really cause much of a harm to your server startup. I would consider increasing the InnoDB log file size as large as the largest hourly traffic. So if you are getting this is something you can figure out from your monitoring, what is that value, but do not hesitate to increase the InnoDB log file size to help improving your IO performances. Next is InnoDB log buffer size. This is the buffer used to store the logs in memory for the transaction before that has to be written to disk. So if you have large transaction doing a lot of insert, update, delete, consider increasing the InnoDB log file size. Sorry, InnoDB log buffer size. Next is InnoDB read and write IO threads. As the name suggests, these are the threads that InnoDB use for performing internal reads and write operations. So if you see pending read in your NRDB engine RDB status. So you're going to get these kind of hints in the engine RDB status. So go ahead and explore what is engine NRDB status command, and there is a documentation page for that. And you can increase if you see the pending read in pending reads in InnoDB as a hint to improve these variables. Um, okay, so query cache is something I have included here. It has been a common knowledge that uh, mostly query cache is not really helping, and it's an overhead. uh, it is a case sensitive cache storing your query results, and if the query having poor indexing, uh, then I mean, if you have a proper indexing, then query cache is not really important. There is a reason why query cache is removed in 8.0, because if you have optimized queries, query cache is an additional headache for the optimizer to go ahead and verify every time a query is fired whether it is there in the cache or not. So you can check your query cache performance using external cache performance using the uh, monitoring methods, but it is better to look for external caching mechanism. Next is log output. By default, this variable is file, though it is good to verify that you do not have it changed it to the database, or say storing your logs inside database, table. So log output defines the output location for general and slow query logs, and it is best to store logs outside database. Table cache. Table cache. Okay, table cache is in a multi-threaded MySQL system. When a client issues multiple queries in parallel, pointing to the same table, or uh, when the query is pointing to the same table, the table is open independently for each session. Like if 10 queries are pointing to one table, they will all have individual table handler to access that particular table. So this file opening operation creates some or incurs some cost to improve the on the performance. And to improve this, we have a table cache. So if we have like 10 queries using them, and then if any other request come in for the same table, and if the cache is already having the file handler for that particular table, the table cache is useful here. Of course, this requires sufficient open files configured on the system level. So the details are provided in the link that I have included here. So go ahead and explore the table cache and table definition cache based on the same concept. Refer the link there. Let us move ahead with the configuration on system level. Uh, so basically, MySQL writes two kind of things. Very broadly speaking, data and logs. An idea would be to provision individual mounts for those two, right? Like put data in one mount and logs in the other. So it also looks like a well configured system. uh, so first is specify separate mounts for data and logs. Next is about swappiness. So swappiness defines the percent of free memory before activating the swapping activity, right? So lower the value of the swappiness, less likely it is less likely that your database will be database system will push towards the swapping, and the more memory, more pages would be kept in the memory. So swapping is bad for database, and we would love to have things in memory. So consider reducing it to one. Like we do not want to completely disable it. We need to have a little breathing room, but we don't want it to actually swap either. There's a link here. Please go ahead and refer it. Next point to consider is disk mount option. Now Linux maintains 3 timestamps for each of the file, that is modified time, change time, and access time. We can check that using the stat command, like stat file name. You'll see these three options. But anyways, for like database files, like the data files that we are having, we don't really care whether we have the access time available there or not. And since files are accessed very frequently, that's causing additional IO, is better to disable this configuration uh, in the mount options. Okay, finally, I'm going to talk about the IO scheduler. They define the way Linux optimizes the disk requests and schedules their execution. IO scheduler can surely help improving the IO performance based on the traffic patterns, but most commonly, I have seen that no IO operations IO scheduler works better. It is something that can be controlled by benchmarking, but I needed to mention it here. So no op is the way to go. Okay, a dedicated page for OOM. So what is OM? Out of memory situation, where system is pressed for memory, but it has left with none really. So like, why I have included a separate page? Because it is like combination of database as well as system configuration here. The solution here, that system ops, when there is, then when it goes out of memory, it looks for something to kill, like whatever is holding the highest memory, it will kill it and reclaim the memory from that process. So guess if you have MySQL running on a system, what is who is likely to be the target here? uh, to avoid the out of memory kills, we should configure MySQL in the light of available memory. Like if you do not have a lot of memory, and like you have 64 gig and you're saying that okay, MySQL is free to use 100 gig, system is going to kill MySQL that way. So let's understand, like MySQL has memory allocated in two major categories. One is the global buffers and the other is per thread buffers. Global buffers are allocated system wide. For example, INODB buffer pool, it is shared across the all the processes that come inside MySQL, like threads and all. And per thread buffers are like sort buffer. Like if the query is doing the sorting algorithm using the sorting algorithms, then the sort buffer is used for that particular thread. If you see that there are two queries I have used, that's a test box I have been using. I have calculated like estimated max available memory or max memory usage possible with 1000 connection and 500 connections. So present configuration says that I may end up using maximum of 16 gig of memory for 1000, or 8 gigabyte of memory for 500 connections. So if my system memory is say 4 gig, and if I'm configure it for like 500 connections, then I'm at high risk for getting MySQL killed out of memory. So how can we avoid this out of memory kill? Getting out of memory killed. There are a few things we can do. To start with, the first is max connections. So max connection is something that we should consider before uh, it should be a sane value, not something like just because you want to serve 2000 connections, you need to have a bulky system for that. As per current configuration, if you can only serve 500 connections, you should only have it as set as a 500. You should also consider adjusting the per thread variables, and like if your queries are doing a lot of sorting, then consider improving those queries and then reduce the sort buffer accordingly. That way also you can extend your max connections limit. Something else we can do on the system, and it is based on how kernel makes out of memory kill decisions. So there is something called as out of memory score, OOM score, that defines the kernel, that defines the value that kernel refers to kill a process. Like let's say, okay, there's a sorted list of processes, and the top OM score person get killed, right? Process get killed. To save from that, there is another configuration set, OOM score adjust, which adjusts the Linux kernel's out of memory scores for specific parameters. So if you have like OM score adjust of 1000, then it is most likely to get killed. If you set OM score adjust to minus 1000, it is actually going to disable the out of memory kill process. But if you disable that, it may end up freezing your system or even crashing it. So what we do, we usually adjust around minus 800, and that's something good enough value for the keeping MySQL from getting killed. That's definitely not mean it's not going to get killed, but it is going to delay it as far as we can say. The clue here is make sure you adjust your configuration accordingly. Okay, let's go ahead with the DB design. So what are the low-hanging fruit ideas here? This time we will review the database design points, and let's see. So the first point is INODB tables. use InnoDB tables. If there is no specific use case for you to use any other engine, use InnoDB. You know that, like, if you need to migrate to cloud environment, for example Aurora, it doesn't support MyISM. Even clustering solution like Galera, MySQL is a problem. MyISM tables are a problem, right? So consider using InnoDB engine. Next point says that create primary keys for your InnoDB tables. The reason behind this is InnoDB is a clustered index. I mean to say the whole table is stored in the form of a index organized structure. If you do not have a primary key, then you must use a non-null unique key. But if neither of those are present in a table, then we have a problem. In absence of a primary key, InnoDB generates its internal row ID. This process of generating internal row ID is not really scalable. Like at higher concurrency, we can observe the mutex contention for creating the row ID. So have primary key. The next is talking about a varchar primary key. If you have a varchar column defined as a primary key, it's not really a good idea, mainly because, again, it's a clustered index. It is reorganized every time the index is the primary key changes. And since varchar columns, if they are not sequential, there will be a restructuring of your index again and again. Next point is UUID as a primary key. Like it's been talked about a lot, and there are blogs in place, so do refer to that. When UUID begins with a timestamp, known as the quasi-sequential, it's not really a bad idea to use UUID, but generally UUID is very similar to a varchar column, so it's not a good idea to use UUID that way. Finally, auto increment. Well, it's a common choice. So naturally occurring primary key, if it is not there, then go ahead and use an auto increment primary key, but have a primary key is the message. About integer types. When we create an integer type, by default, it is created as signed integer. And if you do not really want to store negative values, for which I have seen, like in majority of cases, if you are using integer columns, you do not really have need to use a negative values, so it is a wastage of storage. For example, a signed integer can store 128 positive values and 127 negative values, 10. But if we make it unsigned, then it will allow you to store 255 values. So if you really do not need to store negative values, then it is a wastage of storage that way. The last point is about align. I would like to say that text is not to store the text information. So this is something coming from my experience. Like the line is really stupid. The text is do not use text to store the text. But what I mean to say here is, like, in my experience, I have seen like a tables having like 10, 20, 10, 12 columns. One have a primary key, and then there are 11 text columns. The text, I mean to say text data types. These text data type columns are physically accessed. They causes additional IO and really are high on the storage requirement size. So text is just an example. The message here is use appropriate data type for your table definitions. Okay, we already talked about primary key, so let's not forget to talk about secondary keys too. What are secondary keys? They are indexes helping to improve the query performance other than primary key. Some quick tips would be to consider the cardinality of the column before you index them, right? Like if you have low cardinality, if you have a Boolean value, indexing them is not really going to help you every time you're going to include them. So do not index columns with low cardinality. Then do not include your primary key in the secondary indexes. Like InnoDB secondary indexes by default include primary key to the end of the leaf node. Like it refers to the primary key from where it fetches the data. So that's also a message that it is ideal to have a short primary key because it is appended in the backside of the secondary key, and that way it will reduce a short primary key will reduce the size being used by the indexes in total. Next is composite indexes. So composite indexes are like multi-column indexes where they, if you create the query, when the query has multiple columns included in where clause, the composite indexes come handy. Like if you have name, then date, first name, last name, and date, then all the queries includes only name, name and last name, last name and date. All three query will be optimized using just one composite index, right? So if you specify column on the right order in the index, so single composite index can speed up several kind of queries in the same table. You don't need to index all the columns in a table. It's only going to use one of that. Uh, uh, a covering index. Covering index is a special kind of index in the ANODB where when uh, covering index is in use, all the required fields for query are included in the index. So that's why it is called as covering, because if all the columns in select, in where, in order by, in group by, if they are there or they are covered by the index, there will not be additional disks, or it will not need to read the table actually to fetch the values. Data is directly fetched from the index. One quick note about indexing the dates. At the times you need to process data within specific date range, right? You don't really care to process the whole table, or if you're storing data from like a decade, what you need is only a week long of data. So you will have a range query there, like just process the where date range is last 1 week. An index on date columns comes handy in such cases. The one thing to remember is that when you have a range search done using an index, no further columns are used in that index. Like if you have, as I said, like your first name, last name, date, and then if you have like first name, date, and last name, and you have index used for first name and date, but then the last name will not be searched or scanned using the index, but it will be actually a table scan. So the idea here is, or message here is, put, if you're using a date column in a composite index, put it towards the end of the index. Okay, so now these are the basic tips about indexing. It's not really a primer. I have not even included examples. So there is very interesting link I have placed here for helping you in index design. Go ahead and check it out. But these are some points I definitely consider while you're reviewing the indexing. All right, next we'll talk about the querying. So what are the low-hanging fruits in querying the database? Well, do not use select star. Not saying do not use it, but if you do not need to read all the queries, you don't need to use star. Fetch specific queries columns only. This is going to reduce additional IO and network traffic requirements. Don't put your business logic in SQL. I see a lot of queries using like if else, and then cases, case structures. This is like a programming language. So put your logic in your code level and push only simple queries to the database. Like I have seen routines and stored procedure more than 400 500 lines, which really had complex business logic in there. Okay, next is an idea to use comments. So you can use comments, and it is a good idea to identify where that particular query is coming from, and that way it is easy to debug. Like this is a very dirty query, but you know that it was proudly written by someone called Kedar, and you can pick that person up and teach him some query optimization techniques here, right? The comments get logged in the slow query, so that's another way to identify like if it is coming from specific code locations. So that's one way to identify where it is coming from. Next is to, when you write a query, use the explain plan against it. So the explain plan for queries will show you the query execution plan, how the optimizer decides what index are getting picked, if temporary tables are needed, how many rows are being parsed, that kind of thing. There also are other extended like extra options like explain extended and explain analyze. So go ahead and check those commands and use them whenever you're going to use a new query or you're understanding your query. Now, if you're running queries for analytics, they may take longer, but you do not really think that it can take 1 hour, 2 hours. Probably you just want to, assuming that it should finish within 5 hours. There is a way to control it, and it is using the optimizer hints. Max execution time, if you mention here, as you can see, I have included max execution time as a part of a query, and MySQL will ensure that the query will not run more than that specified number of milliseconds. Last 2 points. There's something that I see very often. One, do not include wildcards towards the left-hand side of a value in a string comparison. So even if you have an index on that particular column, it will not be used. And same goes for the next comment that says do not use functions. Do not use functions around the uh, column. So those are two things that are going to cause a poor query performances. So keep in mind those things. All right. Next place to identify the low hanging fruits is replication. First thing first, replication is not a backup. Okay, one wrong query on the master, delete query on the master will destroy the data on the replica too. So that is that. In a multi-master replication setup, do not write on the both the nodes. It will create more problems than it will solve. So if you have data discrepancies on that particular instance, then it will become too complex to fix it. So it is wise to avoid it. A multi-master setup is better visualized as the active passive versus active standby setup. Oh, next is the configuration variable. I have specifically put it in the replication section because it says that slave row search algorithm, and as the name suggests, it mentions the search algorithm that replica uses while executing the queries from the relay logs. As such, you do not need to worry about it if you are on MySQL 8 because it has been default to nice value. But if you are before that, consider changing it to index scan and hash scan. Okay, moving ahead. Make sure you keep your replica equally provisioned as master. It may have to serve as a standby, and it is also helps it to catch up on the replication. For replication lags, understand that replication is a single threaded process. So while master is accepting writes from multiple threads, replication only have one SQL thread to execute the changes and apply it on the replica. So if replication is lagging, consider parallel replication as one of the options. In parallel replication, or say multi-threaded replication, where we have multiple threads executing changes from the relay log in parallel. So the configuration decides based on the commit order or the write set uh, how it needs to decide the parallelism of the transaction and apply in the parallel. There is a link here. Please go ahead and refer it for parallel application, but it is something that you should consider if your replicas are lagging. Next is consider using the delayed replica. A delayed replica is a replica configured to intentionally lag specific amount of time behind the primary instance. This way, in case of a human error on the master, it's very quick to recover it from the delayed replica than rather than restoring from backup and then picking it up. And the final point, I want to make sure that the replication is having binary logs and log slave updates enabled. If you want to have a chain replication, like say you want to have additional replica under the present one, or if your node is a candidate master, then do not forget to make sure to ensure this variable, because like if primary is failure and you want to promote this particular server, then without binary logs and log slave updates, it's a problem, right? Okay, so that's for replication. Let's now talk a bit about backups. What are some of the low-hanging fruits in backup? What we need to consider here? To start with, do not backup on primary. Backups are heavy processes. They acquire some kind of locks, which may cause the connection spike on the server. For example, the backup locks on extra backup will not allow any DDL to pass through, and the queries following the definition languages are going to be waiting for that to finish. And this is also going to cause additional IO and thus impact the performance. Avoid backups on primary. Next is do not miss to check if your backup was successful or not. Like there are plenty of reasons why your backup may fail. Like it may fail because of the disk where you're storing the backup is full, because of a corruption, because someone else may have killed that process, probably because it is causing trouble. So make sure you get notified and take corrective actions to make sure you have backup processes taking regular backups. Third point, it is very, very important for backups, even more important than backups, and that is about restoration. So if you cannot restore a backup and get the data in the form you want it, then the backups are useless. So make sure you make this as a standard practice to frequently verify your backups by restoring them and validating that whatever you're backing is exactly what you want to restore in case of a disaster. Last point on this slide says ensure the remote retention. So are you retaining your backup on the same machine? What if you lose that particular machine? You cannot have access to your backup, then you will not be able to restore. So ensure to retain your backups on the remote location. S3 and GCS buckets are like very common examples these days I see as a destination to retain your backups. Okay. Next is something with respect to business objectives, like verify your backup against the recovery time and recovery point objectives. Recovery time objective is the how you define the how fast you want to recover your backup from a disaster. And recovery point objective is something how much data loss is acceptable in case of disaster. For example, if your recovery time objective is 1 hour, your backup strategy is using MySQL dump, and your data size is 500 GB. You cannot recover 500 GB of data using MySQL dump. I really wonder, like, if you can. And then similarly, if your recovery point objective is say 5 minutes, you are only okay to lose 5 minutes worth of data in case of disaster, and you are not backing up the binary logs. Then that's not fair. So make sure you validate your RTO and RPO against your backup policies. So there's a very interesting video from my friend Pep here. Go ahead and watch it with respect to backup. Also, we are while we are talking about the low-hanging fruits of MySQL backup with respect to backups, I would mention 3 very common backup tools we use here and some of their properties. So MySQL dump, it is slow to backup and is slow to restore. It is very easy to run that, but it's like most commonly it's like because it's version independent, like it's a logical format, it's a logical backup in SQL format, so you can run it against most MySQL versions. Like if you take a backup of 5.5, you can run it on 5.7. I meant to say that way. But if you're using MySQL dump, ensure that you're using single transaction and make sure that you are aware of the options that you're running against using in your MySQL dump command. Like if you need to restore that backup for replica, then make sure you're using master data option. Next is extra backup. It is Percona's hot backup utility, which is fast option for physical backup and restore. But if you need to understand one thing, that if you have corruption on the file system level, the backup will also be corrupted, and usually this is true for all the physical backups. If you need to have logical backup and you need to have it fast, MySQL dump is something my dumper is something you can consider because it uses multiple threads to backup, and also my loader, the reciprocal command, will use multiple thread to restore the backup. Okay, moving on, let's talk about some of the Percona tools, some of the tools that helps us picking up the low-hanging fruits. I'm talking about Percona tools here. These are almost like 40 tools in Percona toolkit that makes our life easy in the day-to-day operations. I have just decided to list 6 of them. There are more of them that you can go ahead and refer to the link and learn about them. Let's quickly get to know them. So if you need to do table alters, like changes in change or like add a column in a table, add an index, change data type, defragment a table even. So PT online schema change is your key. It will allow you to perform these operations online without affecting your production traffic with minimal impact. PT kill, this command comes handy in case your application is gone crazy, having too many connections simultaneously firing up on your instance, and you need to control your database. PT kill can terminate these queries based on specified conditions. It can, like, you can mention which user, if you want to kill some queries from particular user, or if you want to kill queries that are running for a long period, so you can kill it that way. So that is your tool. Next is a combination of tools that is to identify and fix the data discrepancies in a replicated environment. So let's say if you have duplicate key errors or data discrepancy identified in replication where master and replica has different data. So PT table checksum will identify that for you and pinpoint which database table, row, or columns are having difference of values on primary and replica. And the other tool, PT table sync, will allow you to safely seek the changes and ensure that the data in replica is consistent with the master. PT summary, PT MySQL summary, both tools come handy when you need to identify some of the system and MySQL related information in case you want to analyze them. PT Query Digest is another tool that I use to identify slow query. This tool is handy because it analyzes the queries from log, from process list, like slow logs, from process list, and also from the TCP dump. It produces a report along with the histogram, query runtimes. It records the processed processed rows, return rows, and also includes the log time, etc. to number them in priority to the slowest, to like which needs the most attention to be improved. Finally, the duplicate key checker. It is the tool which we use to identify the duplicate indexes. Removing them will save some space, improves the write performance, and also creates the less confusion for optimizer to choose the correct index for the queries. All Percona tools are free and open source. You can easily get them by installing the Percona toolkit, and just it is also easy to fetch them. Like I just remembered, like percona.com/get/ the tool name. You can get that. Explore them from the link provided in the read link here. Moving ahead with another low-hanging fruit, and that is about off monitoring. If you do not see what's happening, you cannot fix it. So I suggest plucking this fruit by using PMM. PMM stands for Percona Monitoring and Management. This is an open source database monitoring and management and observability tool solution for MySQL, Postgres, MongoDB, PXE, Aurora, RDS. It also logs the information for proxy SQL if you have it in your environment. What it does, it allows you to observe the health of your database systems, explore the patterns, trends, and help troubleshoot the issue if you have it. I have included the links to the slides to explore PMM, to get the PMM, and how to install PMM in Ubuntu. Since this is well supported, documented, please go ahead and try it. Okay, let's move ahead and talk about the clouds. It's rainy in season where I live here, but I will only talk about AWS today. So specifically RDS and Aurora. So what are the low-hanging fruits in Aurora Cloud? Note that do not leave default parameter group for your instance. So if you create an instance, it will have a default, let's say 5.7 or 8.0 parameter group. But if you want to change a particular parameter, it will not allow it. So you will have to make sure that you have a new parameter groups created for the individual cluster and database. It is important because this change also requires the instance reboot. So make sure when you create a new instance, have a dedicated options and parameter groups for that. Second is about HA in AWS. So if you're having a single database instance, consider enable multi-AZ, multi-availability zone instance for your instance. In multi-AZ setup, we have standby replica that provides the failover support and also helps backup. Like backups are taken on the secondary instance if it is there. So the performance on primary is not affected because of that. It does incur some costs, but that is something you need to decide based on your availability requirements, your HA and backup performance. Ensure that your log output is file. Again, we already covered that. And also the next point about MyAsm we did cover, because MyAsm is not supported in Aurora. For migrating to Aurora, there is a low-hanging fruit here that use extra backup. AWS allows you to use extra backup for spinning up new instances, and migration thus becomes very, very fast. A few things we shouldn't miss when you have your cluster or instances AWS is enable deletion protection, to safeguard against accidental deletion, enable encryption, and also enable performance insights. Performance insights helps you navigate some of the system parameters, and it is free for 7 days of retention. Okay. Let's say you run a delete query on a table and you missed a where clause, a delete from table, and there's no where clause. What is your option on the cloud? Well, you can do point in time restore, but that something is going to take a lot of time, because it's going to create a new cluster. So while recovery is going to take time, Aurora has a feature, backtrack, which allows us to sort of undo the last command. So please go ahead and explore this backtrack feature, and use that if you need, enable them if you need in your environment. Okay, conclusions. I have included, copied the very beginning, one of the sixth slide, I guess, here. So if you see why I'm including it, like there is a tomato as a low hanging fruit here. So let me just say the quote. The knowledge is knowing that tomato is a fruit. Wisdom is knowing not to put it in a fruit salad. So the talk here is about knowledge sharing of what are the low hanging fruits of MySQL, which are quick to check and improve, which is based on my experiences in the environment have been supporting. But I expect you to have the wisdom to use it wisely, test it before you go ahead and plug them in your production. All right, so if you have any questions, if you need help in your database architecture, feel free to reach us. Reach out to me, reach out to Percona, even use Percona forums. The links are here. Uh, if you love open source technology, love the Percona blogs, content in them, if you're passionate about what you do or what we do, I invite you to apply for the appropriate position at Percona. Thank you.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello, everybody. Welcome to my talk about PMM, advisors, and alerting for Percona Community Live 2022. I'm going to make a quick introduction about who am I. My name is Francisco Bottleneck. I'm a senior architect working for Percona. I've been working for Percona for almost 10 years now. And my background says I have a database experience of over 15 years with working with MySQL and some other database servers like SQL Server, and a little brief experience on MongoDB. I'm also a microbrewer who loves beer, football, and to spend time with my family. I'm a father of two, and I like to spend time with them. So the agenda for today is a quick introduction about what the PMM is, the PMM tool is, how this integrates with the Percona platform, how PMM can help me to prevent issues and act in case of a problem, using advisors to work on the issues prevention, how the integrated alerting works, how to set up alerts, and finally the integration with Slack, PagerDuty, email, and some communication channels for sending the alerts through. So what is PMM? PMM is the Percona monitoring and management platform. It's a free and open source database troubleshooting and performance optimization platform, especially designed for databases like MySQL, MongoDB, and Postgres. It is designed by DBAs and for DBAs. It also supports tools like ProxySQL. It can integrate support for Amazon and Aurora managed services, not only for the databases, but also for CloudWatch metrics. It supports Azure, SQL, Google Cloud, and the most important is that this is not a software as a service platform. It can be executed on your own environment. It is delivered through a Docker container normally, but it also can be set on as your own appliance or an AMI on Amazon on your own secure environment, even in your equipment. Actually, I'm running a copy of PMN on my own laptop without any problem. It's fully free and it's open source. One of the things I would like to mention about PMM is that it can integrate with the Percona platform to provide some extra features that are not delivered with the regular version or the free version. And actually, I need to inform that it remains being free even if it's integrated with the Percona platform, because there is a free subscriber tier that will integrate advisors and some stuff like I'm going to show you at the end of this talk. But the important thing is that this is not a talk about Percona platform. I will just show up a few integrations and that's it. But it's important to mention that some features or some extra features can be achieved when the tool is integrated with the Percona platform. The platform integrates, for example, all the advisors, and these advisors are checks designed to identify issues and potential problems. And as said, your mileage may vary depending on the type of subscription you are connected to. So, some things to inform about the advisors. They can provide information about security threats. For example, if you have a wide open root account, or if you are using accounts with no password, it will inform that. It can provide information about potential performance problem or degradation based on your configuration. It can show you issues with the potential data corruption or loss, depending on how you configure your instance, and some other stuff that can help you understand what can be do better to at least try to avoid issues. And as said, this is designed and supports MySQL, Postgres, and Mongo. So how PMM can help me? PMM is designed to monitor database metrics. And by database metrics, I mean every type of metric that database creates by just running or attending applications. Based on these metrics, PMM will render some graphics that will help you understand what's going on into the DBA and also understand how your workload is running against the database or how you are accessing to your data using your applications. Moreover, given the presence of the advisor, PMM can help me to prevent issues. And finally, if we have problems, PMM can help me with alerts, like firing an alert if a problem happens. So how to use the advisors? As said, the advisors will come. A subset of them are out of the box in the PMM installation. There are a few of them just to show you how they work, but the real amount of advisors will appear once you are subscribed to the platform. So first of all, we need to create an account on the platform through the Percona portal. This integration is super easy because once you have the account created, like this for me, Percona platform will provide you with an access token that you need to use to connect your instance. Your instance, I mean the Percona server, the PMM server. In the settings on the Percona server, we have the Percona platform that will show a dialog to just introduce a PMM server that you need to define, and then add the access token and connect. That's all you need to do. And for the advisors, you will have a difference or a short. Yes, I will show you a difference about what's the changes between the free tier or the list of advisors versus the list provided once the Percona platform is integrated. So this is a list that comes out of the box. There are like what, 6, 9, 12 of them. But if you connect the PMM server to the platform, you will get way more of them. Just the list is a screenshot, so I'm going to share you later on the demo and how this will help you when running. Finally, once the advisors are set, they will be executed at the specific intervals, and the results will be reported on the PMM home dashboard right here. You will have some checks that will show you critical warnings and notice about different severity of failures. Then I will also show you during the demo. Here is some of the results on the advisor page for those checks that didn't pass whatever is defined on the advisor check. So integrated alerting. This is a feature that Percona is working on. It's still technical preview. It's fully usable, but it's still not production ready. So if you are an early adopter, it's a good moment to start testing that. It is based on built-in templates. So these templates can be created, or some of them comes with the installation, but you can create your own custom templates by defining some YAML files. It's super easy. Based on these templates, we will define rules that defines where circumstance fire alert. And finally, I will show you how we can integrate this alerting method with the communication channel that we define. Email, Slack, Teams, PagerDuty, whatever is your favorite flavor that supports webhooks or some type of communication method like the one I'm going to show you. So how to set up alerts? It's a super straightforward process. We need to define a communication channel that can be a cell, Slack, webhooks, emails. We need to define a template rule. Some of them are already built in. Some of them can be created on a custom manner. And finally, define alert rules. For a given check or a given alert, I'm going to define what condition will fire up this rule. I just defined a couple of them. I will show you how another one can be executed here and do a leave demo on that problem. And finally, I will have an alert page that will notify me if the problem is happening, or if a problem is happening, to be more precise. And this is a small test of how the alerting can appear on my Slack channel. So once we have everything set, I'm gonna move to my demo server and show you how this will work. Okay, this is my Percona platform portal. So here, Percona platform, this is my account, okay? I'm gonna copy my Percona platform access token. And then I'm gonna log in into my PMN server. Oops, okay. Doesn't really matter. As long as we have admin user, we can set up the account. First, okay, let me show you the advisor page and see advisor check, sorry, and see how we can improve them by integrating this with the Percona platform. This is the list of the default list of integrated alerts or the integrated advisors. So let's attach the instance to the Percona platform. In configuration settings, I have a Percona platform set up. I'm going to create a PMN server name. Let's call it PMN leave demo. I'm going to paste my access token and I will connect. So, invalid token. Let's see what's going on. Okay, so I was able to fix the problem with the token. I connected the PMM live demo instance. And now if I go to the advisors page, I'm gonna see the list of checks being way bigger than it used to be. This is again a free account that you can set up, so you don't need to pay for any subscription. And after a while, in the dashboard homepage, I'm gonna get the list of failed checks. So I can click here, and it's gonna show me for my both monitoring instance. I have just two, a pair of MySQL source and replica. So I can go through each of them. This is our source replica and have, like, you know, issues with the configuration variables, some security issues because user has a definition that is not localhost. You know, this is wide open, some details about that, and so on. So this is the way that advisors can help me with to prevent issues. One other thing that I can do once I have the subscription created, I can force to run checks, and all of them will run on the background, and finally provide information on the dashboard, home dashboard. Okay. Okay. Now let's move to the integrated alerting. So alerting, I have integrated alerting here. Right now, there is no problem happening. And I'm going to show you the whole process from setting up a notification channel, alert rules, and so on. So for notification channels, given the purpose of preparing this talk, I created 2 channels. Both of them are for Slack. It's not a big deal. You can create a free account on Slack. I have done that, and once we are on Slack, we can create an application that will kind of open a listener on the Slack side, so I can send a post message that it can show me in my messenger later. But I'm not gonna use Slack for this, or I will use, but I'm gonna use another notification channel to show you how easy it is. But first, let me show you how to configure this. It's not a big issue. We need to create a channel on Slack and then a dedicated Slack room, and then a dedicated Slack channel for that. So for the matter of this testing, I'm going to take advantage of a website called Webhook. Webhook.site will give me a hook where I can send post messages through JSON text. So first I'm going to copy the URL that I need to use, and then get back here, add a channel. What type of channel? I can create email, PagerDuty, Slack, or Webhook. I'm going to use Webhook. I'm going to set a list called, I don't know, PMM hook. This is a name that is going to be used for the rest of the PMM server to identify this specific channel, and the URL that I just copied. I'm going to add that, and that's it. So I'm coming here to my, these templates are the template that comes on the server. I can create more. I'm going to use some of the built-in, and then I'm going to create another rule. I just have 2, and I'm going to create one for the sake of the demo. So you can see how easy it is to add a new rule for monitoring. First, add a rule, choose the template. I'm going to use connections in use of MySQL. I'm going to set something like use connections to identify what is my rule. In this case, I can define a threshold of how many connections are used based on the total available. I'm going to use only 10% of them because I want to fire the problem quite easily. And what's the duration of the condition before firing? By default is 5 minutes. I want this to be somehow immediate, so I'm going to add 5 seconds. And what communication channel I'm going to use? I'm going to use both PMM, which is this one is for Slack, and I'm going to use the PMM hook. And I'm going to activate this. And that's pretty much what I need. Also, I'm going to make sure that MySQL restarted is part of the notification. I'm going to let it in the Slack. So, as you can see here, there are no alerts. And as you can see in my Slack channel, I have just few alerts from previous tests, but I'm going to show you how this works in real time. So let's connect to my instance. And I'm going to do a few things here to force some alerts. First of all, I'm going to stop MySQL. So systemctl, stop MySQL. Let's MySQL stop MySQL. Okay. So the server is not running. Eventually, I'm going to have alert of this problem happening. It's going to take some time. So in the meantime, I'm going to leave a few seconds, and then I will just start MySQL to force one of these. So as you can see, MySQL is running now, show process list, and it was just restarted, 12 seconds. So after a few seconds, I should see an alert happening because of the MySQL being restarted. In the meantime, I'm gonna fire the other alert or the other problem via sysbench. I'm just using a super simple script that will fire up a OLTP sysbench load with 16 threads running. And let's do a quick check before. Show global values like max connections. This is on purpose. I created a max connections on, I'm gonna reduce the max connection to a fraction of that so I can fire up when the 10% is overseen. So set global max connections equal 50. Okay, now I'm gonna fire up my sysbench work. After 5 seconds, I should see an alert here saying that the threshold was is over. Okay, this is the previous one. The MySQL was started. And now I should see, while we wait for the other, let me show you how in Slack we show the new alert and what alert is happening. You know, MySQL was restarted 30 seconds ago, and now I should start seeing the second alert with too many connections being connected because I have 16 over. So this specific alert will appear both in PMM, in the Slack channel, sorry, it's going to take some time because, you know, Slack can be delayed a little bit, but also on the webhook, and you can see here, okay? All the JSON with the information that actually is the same that is happening on Slack. Slack already received this MySQL too many connections. So let's stop this. Let's silence because I don't want that to keep sending messages to my Slack account, not to my webhook. And after a few minutes, both alerts will be cleaned. Okay, silence. This is fire. Oh, yeah, okay. So it's gonna take a few seconds to clean up. Okay. This is a demo. Demo not always works as expected, but you got the idea here. So let's go back to presentation. Some conclusions. PMM is a great tool for monitoring, but also is integrating some heuristics to help preventing problems and alerting in case of the problem happens. So we will work on integrating everything with the platform to have a better and more agile way of communicating problems to the subscribers, because we will at some point be able to create tickets from these alerts. So we will have a full platform to monitor and attend databases from a single place like the PMM server, which will give us some flexibility and powerful features to treat in the future. And that is pretty much it. I'm gonna leave a few minutes for Q&A. And thank you very much for attending my talk. And if you are looking for a new job or some work, feel free to ping us on percona.com/careers. We are looking for people that want to work with us. Thank you very much.
Hi, everybody. Welcome to another Haas Talks Foss. I'm the Haas, head of open source strategy here at Percona, Matt Yakovit, and today I'm here with Vadi from Flipkart, who is one of India's largest e-commerce sites, and they have one of the largest e-commerce MySQL deployments in the world. And I'm really excited to have him here today to chat with us a little bit about his journey and about the stuff going on at Flipkart. How are you today, Vadi?
I'm doing great. How about you, Matt?
I'm doing wonderful as well. You know, it is Tuesday. I wish it was Friday, but it's not. So I'm going to have to just deal with the Tuesdays. So it happens. It happens, right? Vadi, I've been in the open source space, and I started in the MySQL space. So MySQL always has that special place in my heart. I originally started as an Oracle DBA, though, and moved to MySQL later on. Now, I'm curious, how did you get started in the MySQL side of things? Way back in the day. What was your career journey like? Where did you start?
Well, I think if you look at MySQL, it's probably one of the oldest softwares out there and absolutely rock solid softwares, right? And I think for a very long time, one could basically just say that if it is a database, it is MySQL, right? I mean, before all of the other new age kids came to the block, right? Like the NoSQL and stuff like that, it was always MySQL, which did most of the heavy lifting, I would say. So I have been in this industry for about 12 to 13 odd years. And I'm proud to say that I think my first database was Percona, and it's still, continuing to be MySQL Percona flavor for that matter, right? It just talks about how good the product is.
Well, that's good. That's good. And so did you start like coming out of college as a developer, or did you start on the operations side? Did you start like sysadmin? Where did that, the kind of the transfer from, getting into that database space, what did that look like?
Well, I think, so I have never been a sysadmin or a DBA of sort ever in my life. I'm still not a DBA of sort, right? But I started as a engineer, and for the first 12 years of my career, I have been an IC, independent contributor. And it just from the past 2 years of sort, I've been managing teams over here in Flipkart. But yeah, I've been mostly in the developer engineer space, I would say.
Awesome. Okay, so you've been working with MySQL and you've been deploying, and now at Flipkart, I'm interested. Do they have a dedicated DBA team, or do the engineering team, the developers, actually manage that environment?
I mean, it's a very good question, right? I think this is how Flipkart was before the product that we built sort of came into picture. Every team used to maintain their own MySQL databases, and things just to get very, very difficult, I would say, because not everyone knows the intricacies of Percona, or let's even say, not everyone is a subject matter expertise on MySQL, and it always used to get very tough having people having people in the team. So every team had to do this basically, right? And because it was it is still, in fact, Flipkart, in fact, has 2 data centers and a new data center also coming up. And we are not on the cloud where we can directly. So we have a private cloud, and there are very good reasons, monetary reasons, I would say, why we still use the private cloud. There's no on-prem solution in a way, right? Like of having a well-managed, well-oiled MySQL cluster of sort, and that is where somewhere this whole journey of creating this whole managed MySQL sort of began, after looking at all of these problems, I would say.
Okay. And so you had a lot of different teams, each had their own deployments, each managed them differently. Were you part of the process of trying to bring them and consolidate them a bit and that control? Because that had to have been, challenging, just because if everyone's doing things a little different, how do you get them all to conform? That had to be a pretty big challenge.
I'll probably take that question. I'll give you a little bit deeper context over there, right? I think coming from Flipkart is typically it's an e-commerce company, and it is India's largest e-commerce company, right? And we have about 125 million users across India, and managing all of this implies there are a lot of microservices across the entire logistics, supply chain, and all of that, right? And typically, this whole e-commerce business, logistics, supply chain is very transactional in nature, and that basically means MySQL again, because it is the hero of transactional data of sort, right? So when I was part of teams where we were using MySQL for doing in supply chain side of things, right? Eventually, I started also going into, the scale is the problem everywhere, right? So I was managing a team which was managing Vitess. Vitess is the Planet Scale open version, open source version. That was when we also as a team we contributed back to Vitess as well. When it was not Planet Scale, right?
Yes. That was before Planet Scale. Vitess was created at YouTube originally, and then open sourced, and it's been out there for several years now. But yeah.
So it was around that time I started developing this expertise, and people also started associating me with some of these things. And it was around this time I started this project in the supply chain side of things, saying, I want to build a managed MySQL which can solve a lot of these problems of sort. And then what I did was I actually I moved into the platform side of world, where I knew it would be funded of sort by the company as well. Instead of working on supply chain problems, I actually started working more on this specific product for our on-prem cloud of sort, right? And as you said, the journey was never easy of sort, right? Like, so you build it, and then it's always a very difficult task getting your first few customers of sort, right? So what we did was we actually poached somebody from some of these some of these teams which were heavy on MySQL, for example, the accounting teams and things like that, right? We actually poached their MySQL DB onto our team. And then we just told the team that, this guy will take care of your entire stack of sort. You don't need to worry. We'll ensure that your MySQL uptime is, healthy of sort. But behind the scenes, we started, completely managing it, behind the scenes. And that's basically where it sort of started from.
Okay. And now you have this platform. Yeah. That's it's a database as a service basically, but just for the internal Flipkart teams, right? So you're enabling them to add their own databases, their own resources, and everything else, right? Oh, excellent! That's awesome. And I saw in the description of a talk that you have coming up at Percona Live, that you're at 600 clusters, 1,600 VMs, and over a petabyte of data. That's a lot. I'm in all in the MySQL space. So one of the challenges that I've seen in this current environment is, and I'm curious if you've experienced this. When you're working with those development teams, a lot of times they don't have that MySQL expertise. So they build code or they design applications that might not be 100% optimized to take advantage of the MySQL infrastructure. So is that something that you run into where, you have to do some coaching, or you've got some best practices for your developers to get the most out of MySQL?
Yeah, I think as part of platform teams, we call it Funda. Funda is basically a philosophy, right? In very Indian terms, it's called Funda, right? The philosophy is basically it is core versus context, right? So this is what we talk about as a platform. We would want other teams to focus on their core and not on the context, right? So they have to focus on their supply chain logistics and those kind of business functions, and leave the database aside completely, so that we completely manage it. And that's been basically the core of this whole exercise of sort. Did I answer your question? May not be.
Yeah. So, maybe another take on this a little different. Like, so, you're responsible for making sure that the database is taken care of. But Are there challenges that pop up from the development teams or the different business units that you have to deal with quite a bit? I mean, I know in my experience, there's always the performance, there's always the architecture of the schemas, things like that tend to be sometimes questionable, and they cause more issues than the infrastructure in a lot of cases.
I get your point. I think we have tried to build this just like a startup, right? Like to be very fair, the culture is very startupish, right? So what did we do? We said that there are not going to be any roadblocks initially. Initially we were doing a lot of roadblocking, right? Saying, why do you need this size of instance? Why do you need so many cores? Why do you need so much memory? Please go and get your footprint of last year, how your QPS was, and all of that stuff. But then we started realizing that people weren't onboarding. They felt that Steam isn't very friendly enough to onboard. So that's when we said, now is the time for adoption. So we remove all the barriers and say, just get whatever you want. You just get it on the table first. We'll support whatever it takes. I think that was the first thing that we did. We brought everyone. We said that there are no barriers. It's completely no barriers. You can just get your MySQL. We'll start managing it for you. You don't need to worry about a lot of these things. Additionally, what we also said, we said that we have a pool of DBAs also here. And we will basically help you with your optimizing some of your stuff. The system also, what it did is we exposed only some of the variables and not all of the variables. Variables which are simpler to understand were shown to the user. Variables which are slightly harder to configure, like some of the memory parameters which people don't have a great idea about, we abstracted that away from the user and say, you just work with these few variables which are well understood, right? If you need anything more, we'll help you out. So that was, I think, the roadblock of sort which we were able to help teams with, because of which they started onboarding onto us. And our philosophy has always been that you should not need a SME in every team, right? If you have a SME in every team, then the purpose is not being solved really. So so we have tried to help in whatever ways possible so that people onboard to the platform.
Okay, that makes sense. And so as people add, their own applications, you mentioned you have clustering. What sort of clustering are you using right now? What technology for that?
I think it's a standard replication, right? The two kinds of replication that is possible today, the binlog-based replication or the GKID-based replication. We offer both the flavors, right? And people can basically create their own cluster of sort, right? Whatever topology they want to create, can go ahead and create. We are not offering multi-master yet. That is in the works, right? But it's still a single master of sort. But we do offer multi-cloud solutions, multi-region solutions, and stuff like topology, which goes across multiple regions and stuff like that. So
okay, and are you using like some tool for automated failover, like Orchestrator or your own custom scripts?
Well, good question, I think, right? Like, so during the time when we started building this piece out, right, the orchestrator, GitHub's orchestrator, the OpenArc orchestrator, I think, which you're talking about, it didn't really fit in with our use case of sort, right? Especially given the fact that ours is more of a on-prem cloud, which has its own, complexities involved, which is not really, you can't just take it on, put it on AWS or a GCP directly, right? Like this is the on-prem solution. So so we felt that there was the whole it was not matching well or fitting well with our sort of situation, and that's when we sort of built our entire own orchestrator of sort, orchestrator monitoring framework, and all of that was built from scratch here. So it's completely built in for that.
Okay. Okay, and you mentioned you're using virtual machines, so like some people now are starting to explore using containers for the database as a service, but you decided to stick with the virtual side.
So as a company, from the last I would say one and a half years, we are pivoting completely towards the Kubernetes side of things, right? Before that, we were mainly on the VM world of sort, including very large bare metals and stuff like that, right? So this effort of making this whole the product is called Altair, by the way. I didn't mention that. So porting Altair to ensure that it also starts supporting, becomes a operator of sort, and in fact that is also one of the things that we would like to open source it outside once we actually make it compatible with at least a single cloud.
Yeah, because that would be great. I mean, I think that so many people are looking to Kubernetes to be an easy way of managing the mass of systems and the mass of services. It makes sense to kind of fit in the database side, and we're seeing growth there as well. So we have our operators for Percona's products, so we're seeing growth there. And it's interesting that you're starting to move from the VM side to the Kubernetes side. We're seeing so many companies do that because a lot of the applications are being deployed with Kubernetes as well. So I'm guessing a lot of the applications that you support from the database standpoint are already cloud native. They're already deployed via Kubernetes. They're already deployed in that microservice world.
That's right. I think even in Flipkart, if you look at it, we have first started with the stateless migration, mostly the stateless migration of applications which are don't have a state associated with it. First, they move to Kubernetes, followed up with the stateful side of things, because stateful side of things naturally brings its own complexities with it, right? It's not going to be a straightforward thing. You have to think of a lot of things, including how you're going to back up your data and everything, especially if it's an on-prem cloud, right? You have to build some of these things yourself, because not all products out there are completely compatible with any kind of on-prem cloud, right? You can't just take a software today and put it out there. Not everything will directly work, and many of them are not even compatible of. So that's mainly the challenge of sort.
Oh yeah, definitely. And what's interesting is I think some of the tooling and some of these changes are driven by just the size of environments that are growing so rapidly. Now, I know, you had mentioned about 1,600, instances or VMs running, but I'm guessing that's grown substantially over the last few years. And I mean,
growing number, it's a continuously growing number, right? Every day we have onboardings, and every other day people want to expand their cluster, and so it keeps expanding every other day. So.
Well, we do a regular survey, and it was interesting. 2 years ago, the number of people who responded to our survey that had more than 100 instances running was about 20% of the overall population. I think it was 800 people responded or something like that. This past year, it jumped to 40%. So it went from 20% to 40 for more than 100. And for more than 1,000, it went from like 11 to 20%. So, I mean, like in 1 year, right? So that's a pretty significant spike. And I think it's driven by everyone wants their own applications. There's more of these platform requirements where you need each individual system to be managed, and everybody wants their own. So you need these platforms built internally, or adopt a cloud platform where you can automatically empower those developers to move fast. Because when I started, I mean, to build a database system and to build a database setup, it could be a couple days. It'd be like, you set up okay, in a week I'll get back to you with the instance. No, you need that like within like minutes, right? And I think that has completely changed the paradigm of everything that we've been doing in the tech space, is that move fast, get things now. Nobody wants to wait, and nobody can afford to wait.
Absolutely. That makes sense. Absolutely makes sense.
So I'm curious, like this big deployment, you're deploying this platform. What were, maybe highlight a couple of the interesting things that you learned during this journey. Maybe there was one or two things that you're like, "Ooh, I didn't know that was going to happen," or that was much weirder than I thought it would be. Are there a couple of those that you might be able to share with us?
Yeah, absolutely. I think maybe I can share two instances probably.
Okay, sure, no problem.
Right. At least I didn't know about it, and we sort of figured it out. Maybe this is specific to MySQL as well, right? So in MySQL, we started in a typical master multi-slave architecture of sort, right? Eventually, as people started using their data stores of sort, somewhere down the line, we started seeing that everyone is sort of reporting higher disk usage on the slave. So we keep debugging, finding out, why, what exactly, and there's no clear answer of sort, and it would organically just keep happening. You keep trimming it down, you keep optimizing data. Again, after some time, it sort of increases. And we did a good amount of, experiments of sort to figure out what kind of schemas or what kind of query patterns or what kind of data is actually causing this. And we did round about to some sort of rough idea that these are the kind of schemas which are causing some of these this ever increasing disk divergence is what we're calling, right? And then finally we got so frustrated that it's got to be something. So we asked Percona also on the open source community, expecting to get some answer, but then the answer that we got there was, yes, this is expected, and there is no other way except rebuild the node completely. So that way we were sort of happy that we did our due diligence, and then eventually figured out that actually is the problem, and there's no way around it also. And so today we have a automated way of the slaves also keep rebuilding every time the difference between master and slave, if it crosses a certain percentage for the same amount of data, if there is more than say 10% increase in size, then we automatically start rebuilding it off sorts. So that is something we have started doing.
Okay, so basically what you're saying is like the maybe the changes in the system left some empty space, they left some junk out there, and they just need to be cleaned up regularly.
In some way, but it's always been that master is low and slave is high. We have seen maybe 5% of the use cases where the slave was less and the master was higher. That also we have seen, but we weren't able to figure out why that happens. But this is something which happens. Maybe I can share one more very interesting incident or thing we have seen, and these are things that you can only experience in a on-prem solution, right? Because people will not be exposed to a lot of these things if they are using the cloud services or something. So there's this case where you try to so their maintenance is happening all the time on the private cloud, right? Like on-prem cloud, there are TORs, there are racks, there are motherships, and things like that. So we understand a lot of those constructs in the application. Whenever there is a network, a switch or a TOR which is getting rebooted or something, our application basically detects that the database server is no longer available immediately, and then does a failover to the hot standby, and the hot standby comes up, and the applications are continuously writing. They don't even face a downtime because we are also using a DNS in this case. So typically they keep writing. And then what happens is once the network TOR or something is back from maintenance, the old master, which was supposed to have been taken down, that also starts taking writes. You have a split write, you have a split brain problem. These are some of the things I think were very interesting to solve in this whole space, which you typically don't see people solving a lot of these things, because you don't see that sort of scale. And when you operate at this sort of scale, you also see a lot of these edge case, race conditions, and all of these sort of things happening.
Yeah. I mean, it is difficult. I mean, and I think that has led to this whole new kind of industry on observability, right? And it's a big buzzword because now, when you have a couple dozen servers, a couple dozen databases, it's easier to get a handle on things. Maybe you have some scripts, you get some emails now and then or whatever, maybe you throw a monitoring tool out there, great. But when you've got thousands, how do you find the one or the set of servers that is causing the problem when it's only, it could be a dozen, it could be one, it could be, out of 1,000, and that becomes really challenging. How are you approaching it? What sort of tooling are you using for monitoring right now to try and find those problems when they occur?
So we have something called as Cosmos here. It is equivalent of Prometheus. We don't have Prometheus yet, but it's a very parallel software. It's a time series database, and possibly there are teams also using Prometheus over here. But the idea is the same, right? We do keep ingesting a lot of these metrics onto the systems. We have a lot of these scheduled rules or alerts, right? Which you configure it with a certain threshold, and the moment one of these parameters basically go above the threshold, alert is sort of made. So that is the alerting part of this thing, and the monitoring part, we have pre-created a lot of these dashboards for all of our customers, so that they don't have to sit and recreate a lot of these things. So we have cluster level metrics, member level metrics, InnoDB level metrics, system metrics, kernel metrics, and a lot of these things already pre-plotted and everything done. So people just have to, they don't have to really do anything. They just have to onboard to the platform, and they get all of these graphing and alerting and everything for free.
Oh, awesome. Awesome. Well, Vadi, I want to thank you for coming on today, chatting with me for a while about, your MySQL deployments, and talk to us a little bit about the challenge. And those who are listening, Vadi's going to be giving a talk where he's going to go a little deeper into how they've overcome some of these issues at Percona Live. So if you can make it May 16th through 18th, that'd be great. But Vadi, I just wanted to say how much I appreciate having you on today.
Likewise, thanks a lot for having me today.
All right. And for those who are watching, if you like this video, go ahead and like it. Subscribe to the videos, subscribe to the podcasts, and let us know what sort of content you'd like to see, and we'll try and make sure we fill that order. But we appreciate you hanging out with us today, everyone. And until next time, this is the Hoss. Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay, hello everyone. Welcome to this talk of Percona Live on fruits of MySQL. My name is Kedar Vaijnapurkar. I am presently working at Percona as a MySQL DBA in Tier 2 team. I have like 15 years of experience. I live in Vadodara, India. I'm one of the eventual DBA who turned into MySQL from
Hello everyone, and welcome to Let's Talk About MySQL Query Tuning. My name is Gabriel Siciliani. I'm an independent consultant, and I've been working with databases since 2005. I started as an Oracle DBA and then moved into the open source world with MySQL and MongoDB. So this is the agenda for today. We're going to first talk about why it is important to
Hello, everyone. Welcome to the Percona Community Live 2022. My name is David Ducas, and I will be presenting a talk about MyDumper. So what is this talk about? Actually, MyDumper has changed a lot in the last 1.45 years. So we are going to be reviewing the features that we add to MyDumper. We are going to be a high-level review. We are going to also we're going to review the new use cases that those features give us, and also we are going to be reviewing the enhancements that are going to be added on future releases, and how, of course, they are going to be impacting on the performance and the usability of this amazing tool. So the first question here is, what is MyDumper? Actually, this project was started for Thomas Mitusas in 2009 with the first release, which was the 0.1. MyDumper is just a MySQL multi-threaded logical backup tool. The difference is with the other software on the MySQL environment is that it's multi-threaded. Nowadays, it's something common, but when MyDumper was released, initially there was no tool like that. So it has a lot of impact on the community, and also as it was multi-threaded, it was much faster that the only option that we have at the moment that it was MySQL dump. So another thing that I want to clarify is that MyDumper is an open source and maintained by the community. It's not a Percona tool or MariaDB or a MySQL product. This is from the community. You will see that there are the logo of Percona. That is because I work for Percona, but MyDumper is just maintained by the community. Another thing that I would like to clarify is that MyDumper, just the name of MyDumper with a capital M and D, that is the name of the project I wanted to use as like the brand. And then we have MyDumper and MyLoader with lowercase, which is actually the tools that we are using. So first of all, who I am. Okay, I'm David Lucas. I have 39 years old. I live in Argentina. I studied computer science. I had a degree on computer engineer from the University of La Plata. So I have been working since 2009. So I have been working with MySQL for the last 14 years. I started with a small company here in Argentina, which is a consulting company, which calls consulting. Then another 3 years in Bottleneck, which is an online classified company. And then finally, for the last 8 years in Percona. So how we end up here? Actually, on 7th of September of 2020, Max Bottleneck, the previous maintainer of MyDumper, just asked me if I was interested on MyDumper. And I told him that honestly, I was interested in MyDumper for a long time. And that was all. There was no interview or anything else. It was just asking me that if I wanted, I say yes, and that was it. So why do I love it? Actually, there are 3 things that I love about MyDumper. One is that it's related to MySQL. I'm a MySQL DBA for a long time, so it's something that I love. Then these are multi-threaded programming, and it's very complex, but it's really, really interesting because there are all the times new things that you need to solve, new problems that you need to solve, and in a multi-threaded way is something really interesting from my point of view. And of course, it is written on C. There are people that love to program in Python, Perl, or whatever. I like to write in C. So that is why what I love it. Now let's back to MyDumper. So let's start with the past of MyDumper. The idea of this part is to review some of the features that we add, and also to explain how did we do to back this project back to life. It's not just about MyDumper, it's also my personal experience, just to know that probably there are going to be some technical details that are going to be missed. So the first version that I released was on 2021, on January 2021. It was the 0.10.1. At this point, I had no experience on a project, a development project. So because mostly in my career, I have been working as a DA. So I performed no change in the code. And from September to January, I had to understand the MyDumper building process. That was really, really important for me. I took that time in order to understand the whole process. And I didn't perform any change in the code. It was impossible at the time for me to understand the changes that were needed. So, but what I did is I took the decision of removing support for L6, and I add Bastard and Bionic which were not there at the time of the last release, which was like 1.5 years before the time. So I released the first one, and then on March of 2021, I released the version 0.10.3. At that point, I started to merge code. There was a lot of things that were as a pull request, which I add. But I still was not the owner of the whole project. So I was able to review this and understand the code. And I performed some changes. Also, I had to ask Max at that point to merge the code, because I was not fully, I was not the full owner of the project as I am right now. I also started to focus more on my loader, because my loader at that point, actually, it is a good tool. I mean, at that point, it was a good tool. The performance was pretty good. And but my loader, they need a lot of love. So I focus more on my loader. So that's why we are going to see that most of the change at the beginning were related to my loader. So I started on May of 2021, the version 0.10.5 was released. I started to write my own code. At that point, there was not a lot of things that I have been doing. I mean, I have been merging old code, but not my own code. So at that point, I take the ownership, the full ownership of the project in terms of development. So I started to add and find things that I wanted to my developer to have. For instance, one simple thing that I did was the password obfuscation or adding the push mode. These are just a couple of examples of what I did or what are the things that I add to the project, which I thought that were going to be really, really useful. Of course, there was several bugs that we have fixed, and we started refactoring tasks. We need to understand that as my dumper has been there for a long time, the code was pretty old, and in order to implement the new features, we need to change a lot of things, things that had not been changed for a long, long time. None of the change that we did at that moment has a performance benefit. I mean, we were just moving code and try to make it to fix bugs, but no performance benefits at the point. So in July of 2021, with the version 0.10.7, we are starting to things that are going to improve the performance. So in order to my loader to be better, we have to give more information, and that is why we add the metadata file per table. Now, before that, my loader didn't know the amount of data that is going to be inserted. After that, my loader will know how much rows are going to be inserted, and in order to import the largest table first, that is the only way that we have to know the amount of rows beforehand, and we did that in my loader, and now on my dumper, and my loader will know that. Then there were a couple of features that were released. We add some features that were easy to implement. Those were the word support, the disable real log, the rest sync wait, and the order by primary key were some of the features that I say, okay, this is really simple to implement in my loader and my dumper, so let's do it. The one that was not easy, but it was really, really useful is the checksum of the table. That is really, really useful and was the first step in order to perform the tests in a better way. This is another thing that we have been working a lot lately, which is to have better testing. That is something that we want to have in the future releases, to have more stable releases, and for that we need things like the checksum tables. And of course, the first important performance impact feature was the artifact integration. At that point, the tables were being created with all the indexes. Since we implement this feature, now the indexes are creating after the whole table data is inserted. So that was like, at that time, was the first performance impact feature. So on September of 2021, we released the version 0.11.1. This was a release that performed changes, very important. That is why we changed from 10 to 11. The main reason why we changed the number is because we implement the database and table file renaming. That is something that we had to do in order to support all the file lengths that MySQL allows to have, but at OS level is going to fail. So we had to start renaming the tables and the databases names. So we keep a hash table inside my dumper in order to keep track of that. My loader, on the other hand, needs to know if that was a renamed table, and of course change the name or keep the information internally, checking the file name, checking the file content. So another change that we did at that point was related to the estimated state. There was some logic in the code that was not being used, so that is why we perform some changes in the code, and we create the shows accordingly. Another change important was the configuration file. We are starting to use the configuration file to set the variables, the session level variables that we have, because there were a lot of requests that they want to execute at session level, or change things at session level. So we decided to stop doing that on configuration file in the code, and start using the configuration file, and that was it. Another interesting feature is the parallel table creation. So it was very simple. Previous to this, MySQL was creating, my dumper was creating the tables one after the other one in a sequential order. So we decided that it was possible to do it in parallel. I mean, we are a multi-threaded tool, so it was the logic to do it in parallel. And then we have to disable that because on some scenarios, if you have the foreign key creation on the newer version of MySQL, you have issues. So even though that you can do it in parallel, in certain scenarios, you might not need it or want it. So you are allowed to disable that. Then there were a lot of work, refactoring work. There were duplicated pieces of code, unnecessary logic. We had to unwrap code. We created new functions, and we had been splitting the code. Actually, we were making more mess just to understand what we are doing, and then fix all that mess. For sure, we have been adding more structures, lists, and hashes, as we need to understand better, to be able to, I mean, to build the code in order to be able in the future to add more logic and features. At that point, we knew that if we continue doing things just patching, will not make sense. So we try to add better code in order to allow my dumper, the project per se, to grow. All those changes that we need at that point, some of those changes were introduced in that release. On November of 2021, we released the version 0.11.3. It was a very good release in terms of the features that we had. The stream was one of them. This was like another feature that impacts in the performance, and of course, it opened new use cases because now you can start to restore while the backup is running. The other features that we add that impacts in the performance is the CSTD. Because it's reduced the amount of I/O needed to write all the whole data, and of course the speed of backups is much faster than GCP, which was the other implementation that we have in my dumper, and it's like a real-time compression, so it's much faster. Another thing that CSTD give us is that as we were writing at faster and using less disk space, then you can start increasing the amount of threads on the my dumper side. So that is another thing that you might need to consider now that you're allowed to use CSTD, that you can even increase the amount of threads on my dumper. So another thing that we started at the time is the data masquerade functionality. So we implement that in several phases. Actually, there is one phase that we need to implement on future releases in order to fully implement the data masquerade. And of course, there are a lot of bugs that we have been fixing. We reach up to 5 releases for bug fixes. And that is because we didn't have enough testings on the releases. On December of 2021, we implement the partitioning, the split partitioning. I don't know how useful is it, but there was for a long time it was in the pull request list, so I wanted to implement it partition for people that they need. Then what we did, which was really important, is to add better logging information. So the many jobs in the queue, it was things that we add to so the user can check how much data needs to be inserted or executed or reviewed. Also, we add the version of software on the backup, because if not, you didn't know which was the version, because we don't have the backward compatibility. So you need to know what version the backup was taken in order to import with the right version. Then the late tracking error, that is another thing that is really useful when you was importing the data. It was if an error occurs, you didn't know what exact line of the file, because the failure were related to the insert statement executed, not in the file. It was just for the insert, and you know that you could have multiple inserts in a single file in my dumper. We also add the load option, the load data option, and the CSV, but in the way that we implemented, you will be able to write probably every format that you want in order to output the data. We also integrate with Circle CI and Docker, which was really important because there are users that they want to use Docker for their environment. And my dumper didn't have his own deployment or container. And Circuit CI was really useful, and we are introducing more functionality to Circuit CI because we want to start performing the test when we are pulling a new code to the repository. So the testing, and that includes all the testing. So not just compiling, it's also the test that we want to perform. Also, okay, then on March of 2022, which was one previous before the last one, we implement a lot of features. We did the anomaly function for that masquerade. We started the second phase there, and we finished that. At that point, we were able to get the information from the configuration file. We add the stop and resume, which need a bit of love, but at least it is there. So now if you press Ctrl+C and the backup is being restored, you might not need to cancel the whole thing. You can just resume and continue, but if you want to stop it, you're allowed to do that. So also the compression, we added the compression for temporary files when we are streaming, because that you weren't allowed to do that before. It was just the SQL file, non-compressed files, non-compressed backups were allowed to use with the stream. That last change, but was just for temporary files. So at the end, when you were streaming, it was just non-compressed data. So it was like 3 steps to get to the final stream and compression functionality. We also add filtering options on my loader, so you have the same things on my dumper, but you can also skip the trigger or skip the post. So it was like you can filter on my loader too. We also add the functionality to combine -R and -F. That one is for chunk by rows, and -F is to chunk by file size. So now you could have both, which is really useful if you have multi-column primary key. Also, the pass when there was not enough disk space. So and logging the transmission rate. That's also other functionality that we add, because we wanted the user to have more information about the backup. Also to know what's going on, it was to take their own metrics. And as we did the parallel table creation, we need to the sequential table creation, because we found that there were some issues related to the foreign keys on MySQLite. Also, we started refactoring tasks in order to split my loader. My loader at that point, we had a lot of functionality, and the file size was reaching to the 3,000 lines. And we say, no, this is getting too big, and it started to split on several files. And then the latest release, which was on May of 2022, It's a version 0.12.3. It has the full compression support on stream. This is extremely useful because now you are just copying the files and we are sending the file completely through the stream. We are not changing anything else in the file content. There was some refactoring on the DDL locking. We had to review all the lock mechanism that we have. Also, we started using Bygreen to review the memory leaks, and that is something that we are going to start using. We are going to try to use on every release. And we're starting to split my dumper because we already split my loader on the previous release, and we found that it was really useful. And then we started to with the same process on my dumper. We just split the code, but we try to maintain the logic of the offsets in each file. And the other thing that we add is the support for PMM to show users what my dumper was doing, my dumper and my loader, because it is on both. So you might end up with graph like this on PMM, which is really interesting. We are using the file collection for doing this kind of graphs. Okay, so now the new use cases. So all the features that have been added allow us to give you new use cases. So we already reviewed what we have been doing on these last releases. So now we are going to review the new use cases, what those features allow us to do. And those new cases are given by stream and also for with Masquerade, which is not fully implemented, but we wanted to share what are the opportunities here. So before stream, we have the common use case that is that my dumper connects to the database, write the data on the file system, and then my loader is going to read from the file system and connect to the database. There are multiple scenarios, and you can have that. The only difference, for instance, are if you need to copy from one server to the other one, but then it's the same. You are just reading from the file system to import the data. With the stream, there is another opportunity that is that you can start the backup, start the restore, even if the backup is running. So my dumper connects to the database. My dumper is going to write the data on the file system. But after the file has been closed, and remember that you have chunks per file, as soon as the file is closed, the file name is going to be pushed in the stream queue, which the stream thread is going to read, is going to open the file and pipe to standard output. That is how we implement the stream functionality. So we need the file system, yes. And we are streaming to the other server, which is going to be creating a new file, and it's going to store the data, and it's going to enqueue on the process, but depending on the file, the kind of file that we have, if it is schema data or a foreign or a trigger or whatever, it's going to determine when that file needs to be executed. So my loader is going to just, at the end, is going to read the file and import or execute the commands inside the file. So as you can see, there are new scenarios that were impossible before, and there is an interesting one, which is that we can keep my loader hearing from the network using NC, and multiple execution of my dumper can send files to my loader in order to import data in parallel. So that's another thing that we didn't have in the past. It wasn't possible to think that my loader was going to be able to read files on the fly and import, and that you can, that you could have multiple execution on my dumper. It was like crazy. At this point, this is really useful because you can just you could this is useful for QA environments, for development, if you want to create these pieces of tables on the other environments. This is a way to do it, and do it really fast with my dumper and of course with my loader. Even though you can do it, use my loader if you want to load data on a production, even though from your application, just you need to take into account the format that we are using, which is the find them, and then there is insert statements. Then about masquerade, this is something that my dumper was not designed for. It is something that is for, again, for developers to build new environments. It works. We try to do it as simple as possible. So we perform the select as we are using for any export. Then this is how my dumper works. It creates a MySQL row with data structure. Then there is a function that is executed and modify the data inside the MySQL row. And then we insert that data on the files as we do on every execution. So this is really simple. Right now, the function executed on every single execution of my dumper is the identity function, which is the one that returns the same value that you are passing as argument. So it's really simple. But the idea is to add other functions that are going to be modifying the data and actually changing the content. One really useful thing that we want to add to this is the option to keep a hash of the data. I mean, every time that we ping to this value, I mean, we want to access this value. The value returned is going to be all the time this one. So this is really interesting in order to keep the cardinality of the data. As for instance, every time that you try to access the ID number 3, which will match to ID number 5 on your destination database, keep track of that. So every time that you see on your database the value 3, it's going to be the number 5 is going to be returned and written on the backup. Well, now I wanted to go a bit deeper on the important features that we add and the impacts on the performance. Those are stream, CSDD, the identifiers in the creation, and the product table creation. So streams allows import while export is running. This is really useful, and if you need to start your restore as soon as possible. I consider that this is less steps, so allows you to reduce the copy from one place to the other one, and as you can do it in parallel, is just much simpler. It's just less step and in parallel. another good thing is that can be combined with other options like compression and file index creation. So that is, I consider that is really useful how we implement and that we are able to do that. Another thing which is important is that now you can send everything to a single file, which was one awful thing my dumper has, that a lot of files were going to be created. So in this way, we are reducing the amount of files that are going to be created. CSTD, it was really easy to implement CSTD. We use just a GCP wrapper. We didn't have much on the code, just we added the wrapper and we linked the library, and that was it. Another thing is that speed up the backup. We are talking about 50% of the time less. I mean, it's incredibly fast. And of course, there is less data to write or to transmit if you're having in the network, or if you want to store it, it's going to be less disk space needed if it is compressed. So less time, compress it. So it's a win-win scenario. So in InnoDB fast index creation, we implemented this on my loader. Nothing was changed on my dumper. On my loader, we are creating, we have the first step, that is create the table without any indexes. Then we need to create 2 jobs to create the indexes and to create the foreign keys, which are not created at the same time. This is really useful on large table with a lot of indexes. As if you insert on a table with a lot of secondary indexes, it might take more time when more rows are inserted. So what we are doing, which is something that we already know, but that we are inserting all the data at once, and then we are creating the index in a second stage. Another thing is that you can create the indexes I mean, you start with inserts on one table, and after all the inserts have been executed, you start the alter table on that particular table, but meanwhile you can insert on another table. That is really useful. We also have the option to insert when all the inserts can be executed. The idea is also to implement per an amount of threads. I mean, you can have, I don't know, 2, 3, 4 alter tables that are adding the index at the same time, but not all the threads working on the alter tables. So that is another thing that we need to have, which is not released yet. The parallel table creation, that is, I want to point out this because it was really useful for database with a lot of small tables. But the other thing to take into account is that this might have issues with foreign keys. So that is why we had to implement the serializer. So you are allowed to create the tables in parallel, which is desired for most of us. But as there is an issue, we need to also to disable this functionality. So if you are not foreign keys, you are free of any issue. If not, you might need to take this into account. So I wanted to let you know that set a couple of tips. For instance, how to speed up dumps. I already told you, but my dumper is not one of the tools that we had to improve the performance too much. Probably the functionality, but not the performance, because the performance is quite good. So what you need to take into account in order to do not have performance issues is to use -R, which is the option that splits the files per row. I mean, the amount of jobs at database level. The idea in the future is to determine the best chunk size based on the query time. That is one of the features I wanted to add to my dumper. And also taking into account the minimal amount of rows that we can set in a chunk, and a maximal amount of rows for the chunk. That is like the most important thing that you need to take into account to speed up dumps and what we want in the future. Then for sure, use CSTD. That will speed up the dump always. It's incredibly fast. It reduces the 50% of the disk space compared with a non-compressed execution. So if you want to speed up dumps, just use STD. So, and how can we speed up the imports? So that's F will increase the amount of files. Yes, it's true. But it's also going to allow my loader to import in a multi-thread fashion. Why I'm saying about -F, if I already told you about -R in the previous one, well, -R is mostly for splitting the jobs that are taking the data. That's -F, which is the file chunk, is going to allow you to always have the chunks that my loader needs to use a multi-threaded functionality. So and it's the same for you. So at the end, it's going to be really useful to set by default both variables. The other thing is just to disable the real log, but you need to take into account that this is not recommended to production, because you are executing the alter instance disabled the reader log, which could cause inconsistency if your database crashes. And of course, you need to use the correct configuration. You should set the INOD flush method log to autodirect, the INOD auto log mode equals 2. The performance schema, you can disable the performance schema in order to reduce the overhead. Disable the bin logs, or directly sync bin log equals 0. The INOD flush log at transaction coming different to 1. You can disable the double write INOD, and of course you can enlarge the INOD log files. Some of these variables doesn't make sense if they use together, or if you are, for instance, disable the read log. But depending on the case, you might want to use some of them. So, future releases, what we are going to be adding. The idea is to have a single file per table. This is something that people desire, and we are going to allow you to do this, but not inside my loader, which is going to be really complex to implement. So this is going to be done outside of my loader, like in a second step, using, and what says in the second line there is the pipe to another process. Actually, as we are allowing you to execute on my loader, on my dumper, some external command after a file is being created. So you are going to implement with an easy script that I already wrote, you can implement a script that after a file is being written, you are going to moving the data to another file. So internally, we are not going to be implementing a single file per table, but we are going to give some kind of solution in order to do that with the pipe to another process. Then we want to improve the PMM text file collection. The implementation is good, but we want to give the user more metrics. So that is some things that we are going to be doing in the future. We want to automatically determine when to use, when should not be using the binary optimized table keys, because, for instance, with tables that doesn't have minimum rows, we should be disable that. So that is one to keep on my dumper or my loader to be automatically done. So of course, this is something that I already told you, but the best chunk size per table. So we want to chunk or create the shops that chunks the data on the tables in a dynamic manner. So in order to be in terms of the query time, not on a static value, which is what we are doing right now. Right now, we estimate the chunk size, and we use the same chunk size all the time. So if you have holes in the primary key, you will the amount of rows will be less. Could end up with empty files. In order to reduce that, we are modifying the chunk size. That is what we wanted to implement in the future. For sure, we want to refine the code. We want to have better testing. That is something we are already doing with Circle CI, and start using Valkyrie on every release. We are targeting to develop the first stable release of my dumper this year. We are not sure if we are going to be able to do it, but we are going to try. The release we were doing every 2 months. Right now, we decided to do it every 4 months because we want to focus on the testing and the quality of the code. So, expected performance gain. So when I started this talk, and this is about the future of my dumper. I told you that we were going to be discussing about, at the end, it's going to be 2 things, which were the use cases and the performance gains that we expect to have in the future. So in my dumper, will be very, very difficult because my dumper is pretty fast from the beginning, and there is not much to do there because the only thing that I can think that we could add in order to improve the performance of my dumper is to know which tables are in the InnoDB of a pool and start with those tables, but that is not possible. So there is no way that we can know that. So there are not possible for that. The only thing is to improve the locking mechanism that we already have. And there are some opportunities there, just we need to still investigate in that, but that is the only thing that we can think of. So in terms of performance on my dumper, there is not much, but there are a lot of things in terms of usability. So there are a lot of things that we need to implement, but not in terms of performance. In my loader, actually there are things, and they are difficult to explain, but actually they are related to how we can split the inserts that are inside the file in order to improve the performance. I mean, on each file we have multiple inserts, so probably executing in parallel will be faster, maybe not. We need to test those. And that is what we are going to be doing. We think that we might have an opportunity there in order to, in terms of performance. So we are going to be working on that on future releases. That is another reason why we are also adding PMM, in order to have metrics about the import times. So we are focusing mostly, our main focus is increase the quality of the code, as we know that we need to work with more people. We want other people to join to our project, and they need to understand the code in order to introduce new changes. Because usually when people want to be on the project, it's because they need a functionality that we don't have. So if we change the code in order to make it simpler to understand, more people is going to come. That is what we think. And of course, we want to add more use cases. So now that, for instance, right now, we are going to be able to execute other programs while my dumper is running. This open a lot of opportunities. Same that when we implement with the stream. So now, for instance, you will be able to use encryption. You are going to be merging the file. That's what we are already doing. I don't know, if you want to compress with not zip or other option, you are going to be able to do it. So now that opportunities are there, so you are going to be able to start using that. And there are those new use cases that what we are going to be focusing in the future. Okay, so that was it. As this is a recording, you might not be able to ask me anything. So just if you have any question or you have a bug that you want to report, just you can set that to the repo, or GitHub repository, and I will be happy to answer. I wanted to thank you all for watching. I wanted to thank also to Percona to give me the opportunity to present this talk, and to my dumper community that every day help me to build this tool and to make it better every day. Say thank you all and see you around.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hi everyone, my name is Alawi Assagaf. I am a database engineer at 8x8. I have been working the past 6 years for Fuse, and Fuse was acquired by 8x8 earlier this year. Both Fuse and 8x8 are specialized in VoIP and unified communication services for businesses. In today's presentation, I'm going to be discussing MySQL production configuration with Proxy SQL and Orchestrator. This presentation is divided into 3 sections. In the beginning, I'll start with an overview, a statement or a general overview of what the problem that I'm trying to solve in this presentation, and then I'll move on with a quick overview of each technology I will be working with, starting with Orchestrator and then Proxy SQL. Throughout the overview, I'll go into some configuration options and some decisions on why specific configurations were used. In the second part of this presentation will be a quick discussion about different use case scenarios based on the configuration we have done in the first half, and explaining how it's going to be working in these different use case scenarios. Finally, there will be a quick demo so you have a taste of how this works in real life. Okay, so the main problem I was having the main problem I'm trying to solve is decoupling from applications. Usually, whenever there is a change or an upgrade that needs to be done on the databases, we need to plan with application and dev teams. Depending in the scenario, this could be very complicated or very simple, but in many cases you will need to plan with the dev teams for a downtime, for a release schedule. Maybe some changes are required in the application side as well. So I'm trying to decouple from this so that the database changes can be independent and doesn't affect the applications directly. Give us a lot of freedom and flexibility in terms of implementing and deploying changes in the database section. This helps, of course, with making changes smooth and simple. Another problem I was trying to solve, or at least I'm aiming to address in this presentation, is having no specialized hosts. There are different kinds of setup where you have obviously the master and the slaves. Sometimes the master is configured differently than the slave because the master maybe is having higher rights and the application is doing more writes than reads, or vice versa, where you have the slaves with more horsepower than the master. Maybe you have different specialized slaves for specific applications that would handle special loads, so you will configure them differently than the others. For me, this introduces different kinds of problems, challenges with the management and even with the configuration when it comes to configuration management. So having no specialized hosts, unique hosts, instead make everything unified was one of the goals that I was trying to address in these designs. Of course, read scalability and high availability are obvious requirements. On top of all of that, I wanted all of these features in a simplified setup. Might be asking too much, but we'll see. And I have seen different ways Proxy SQL and orchestrator configured with console. In this presentation, I'm not going to be using console. Based on the point mentioned earlier, I'm trying to simplify the setup, so trying to make it with less moving parts and less components as possible. Nothing wrong with using console. It's just that this is the way I decided to make this this setup. Obviously, console could be introduced in the design I'll be presenting today. Both orchestrator and proxy SQL provides rich features and various ways of tuning and configuring it. I will be focusing on relevant configurations, relevant aspects of each technology. It's not going to be a dive in. I will reference some links that you can read if you wanted to explore more into some of these options. Load balancers will be discussed briefly in this presentation, but the options will not be discussed. It's assumed there are so many different load balancer solutions. Whatever load balancer you choose, whatever is your favorite, is fine as long as it's implemented one way or the other. We will get to that point later on. Okay, so to visualize what I'm trying to get to, so imagine this simple setup where you have a master and 3 slaves. I want to be able to start pushing changes on the different nodes one by one without causing any downtime or problems in the application. So no one application is dependent in any of these slaves. I can take them down anytime, push the update. The red means updates have been pushed. Now all the red are the same configuration or receive the same update. The master is still there. I want to be able to dispose of the master without worrying. And if I want, I can refactor the master and the old master and make it join the cluster again. The reason I'm calling them nodes is to kind of illustrate that they are all identical. None of them is configured any way differently than the others. All right, so orchestrator, for those who don't know, orchestrator is simply put, it's a high availability solution that is topology aware, and it runs as a service, and it provides CLI and web interface for management as well as API. The setup in a high level, I'm going to discuss each point in the next slides, but in a high level, orchestrator is configured in this presentation with SQLite backend using sudo GTID. I'll be going over the master and intermediate master briefly, the configuration for master and intermediate master recovery. I'll discuss how I'm getting the cluster name and the DC, as I will be using that to prevent cross DC failover. High availability setup for orchestrator itself. Okay, basic configuration. This is the top part here is the grant you need for the orchestrator user. There's a special grant for sudo GTID that will be discussed in the next slide, but you need it if you are using sudo GTID, which I recommend. In orchestrator configuration, these are the two options to set the user and the password. I'm just using the default for now, but make sure you change that in your production environment. So sudo GTID, briefly, it's a method that orchestrator implemented to inject the binary logs with an ID that helps it to track and decide which coordinates the slave should be pointing to for the new master, whether during a failover or if you are moving slaves around. The injection would happen on the master, replicate through the relay logs, and gets gets into the slave's binary log, because we need to enable the binary logs, as we will see in few slides. This slave is now ready to become the master if a failover happens, or if we are making it an intermediate master. This way, using this hints, orchestrator is able to figure out where the slave stopped and match that on different nodes during a promotion or a change of master. So, as I mentioned, you need to have binary logs enabled for sure in each slave, because each slave is promotable. In the basic setup, of course, there are options to make to specify the promotion rule if you want specific hosts not promotable. You need to log the slave updates because you want to make sure, especially for the ones that you want to be promotable, because if it becomes the master, if there is another node that would become a slave of the newly promoted host, you want to make sure that it receives the updates it was missing in case it was delayed, or if the position it will be pointing at is different than it was catching up at the master. To enable SQLite backend is really basic options. There isn't anything crazy about it. This link here has a sample for the SQLite configuration, orchestrator configuration. These are the two options you need. This is the reason I went with SQLite. It's very basic setup. It comes embedded with the orchestrator. Nothing, no more setup. You don't have to do anything in the back end. Sometimes you can have MySQL as the back end as well. If you feel that your setup is big, the number of clusters and the topologies you are managing is more than SQLite can manage, of course you can go with MySQL. In my case, SQLite have been good enough. Again, here are the sample configuration if you need to look into it further. Okay, so getting the alias name. This is very important because it does simplify the configuration of orchestrator. It simplifies your automation if you define a cluster name. There are very different ways. There are many different ways that you can get the alias name, including creating a table with rows specifying the cluster name, the data center name, and many different configuration. I have seen that done many times, and if you do a quick Google, you'll find people specifying the cluster name in different ways. Personally, I prefer in general to know what the function of the host just by looking at its host name. And as an example, let's say I have this host which is named MySQL application 1 DC101. So I know this is a MySQL node for this specific application located at this DC, and this is number 1 out of X numbers of nodes. Using this example, it's divided into these sections: the database technology, the cluster name, the DC number, and the host number. Based on that, I can use these queries, which is defined in orchestrator's configuration. You pass this query in orchestrator configuration to pick up my alias and my data center. It's the same query, I'm just specifying which part, depending if it's the cluster for the second and the DC for the third. Again, there are different ways to do this. Okay, so to enable master and intermediate master recovery, it's really basic. You need to make sure this option is set up so that whenever there's a promotion, you want the new master to execute slave reset all. Sorry, reset slave all, so that it doesn't pick up the new master when it comes back online, if it ever does, because orchestrator will kick it out of the topology, promote a new master. you want complete isolation to avoid any kind of problems. This is an important option where you want to avoid a flicker of multiple failovers if there's any problem, network or otherwise. You want to make sure that orchestrator doesn't keep executing failovers one after the other. So this is the default, which is 1 hour. You can change it to whatever fits your requirements. One of the neat features in orchestrator is that you can specify which clusters you want for master failover and intermediate master failover. You can actually specify and separate the two options. Sorry. And here comes the importance of, or an example of the importance of a cluster name. So you can specify which clusters that you are monitoring through orchestrator that would be promoted. A star means all the clusters that are defined in orchestrator go ahead and execute failover whenever there's a master failure. Of course, you can specify the clusters as it's done as an example here, where you specify the names of the cluster that you want to execute a promotion, whether it's a master or intermediate master. So if you clear this, no intermediate master failover will happen. Again, one of the things that I really like about orchestrator is the hooks, because this gives you a lot of flexibility in terms of automation or customization when it comes to failover. If there are specific pieces or process that you want to enforce, the hooks allow you to, at different stages of the failover, to push your commands and enforce your rules and automations. Some of the important hooks, in my opinion, there are more than that you can find in the documentation, but the pre-failover process that once orchestrator detects failover, it will call anything defined in the pre-failover process before executing the failover itself. Watch out though, if your pre-failover script is taking time, failover will not happen until the pre-failover process is done. So make sure it's a quick script or quick command, or run it in the background. Post-master failover process happens after a master failover completes. Post-intermediate master failover happens after an intermediate master failover finishes. Post-failover processes, it doesn't distinguish whether it's a master failover or intermediate master failover. So if there's a specific thing you need to push regardless of the failover, we will use this one. If you want a specific one for master or intermediate master, you will use the previous two. And post and successful failover, if the failover fails, it doesn't succeed, there's a specific hook for that. You can also make use of tokens and variables that will substitute values within the hooks processes. So here's just an example, just to illustrate it. Let's say pre-failover, you want to push a note in the logs, or you want to notify the on-call, or you want to push it into a Slack channel, whatever it is. You can use tokens, so failure type and failure cluster will be mentioned. And again, here, a good use case for naming the clusters. Another example, let's say you want specific commands to run after an intermediate master failover. For example, let's say you have your intermediate masters as writable nodes for whatever reason, and you can execute a command and saying, well, after you do the intermediate master failover, make the successor host, the new promoted node, to writable. Maybe you have some other commands, you can just provide it there and pass some of one of the tokens or the variables as an option. Here's the link if you want to look into hooks further. Some other options that are worth checking is fail master promotion on log minutes, or fail master promotion if SQL thread not up to date. This is if you want promotion not to happen in these cases or delay it. And the last one, which is really important, is if you have specific hosts that shouldn't be promoted. Maybe you have a host that's a backup for specialized for backup, or delayed hosts as a mean of disaster recovery using replication delay. Whatever is the use case you have, you can specify it here. In my case, as I said, I don't want any specialized hosts, so I'm keeping it simple. Prevent cross DC or cross regional failover. You have both options. You can, as we defined our DC earlier, you can also have a query to define the region. However you define your global presence in terms of region and DC, you can have that flexibility. Just for this presentation, let's say I only care about DC. So for example, if your region is US and the UK, those are your regions, and you want to fail over anything that's in the US, but you could also go even in more details and say, nope, I want only to fail over San Francisco or Boston, for example. So if my master is in Boston, do not promote anything from San Francisco. So however you define your presence, you have that ability to control. So prevent cross DC failover. Earlier, I had a query to define as DC1, DC2. So anything, if the master is DC1, DC2 will not be promoted. High availability, it's really important to have orchestrator set up with high availability, because you don't want a failure to happen while orchestrator is not reachable or not functioning, or any issues that may cause it, not be able to detect the failure. Otherwise, what's the point? Raft is an option. There are different ways of configuring high availability. You can use MySQL high availability if you use MySQL as a backend. The link here is specifically for Raft, but if you look into the documentation, you will find different ways of implementing high availability for orchestrator. This is specifically for using Raft. I'm using SQLite. You can use MySQL, but as a standalone backend, so no replication, and you will still be able to use Raft as well. Straightforward options: enable Raft, specify the directory, bind address, the port for the Raft, and you need to specify the orchestrator nodes that are part of the Raft cluster. Now, it's important to have it in different DCs availability zones, or however your data centers are divided. Just in case there's a network problem, at least you have 2 or 4 if you are going with 5 orchestrator cluster that are still functioning and able to execute failovers. All right, so that was orchestrator. Moving forward with the proxy SQL. Again, for those who don't know proxy SQL, it's a layer 7 proxy. I have seen it being confused as a load balancer. It could function as a load balancer, but it's not really meant to be specifically a load balancer. As described in the website, it's a workload management service. It provides many features and different ways of tuning the workload to fit your use case and to fit your needs. I have been using proxy SQL for over 2 years, and I'm happy with it. I'm really happy with it. You can divide some of the important features is that you can define host groups that you will define your query rules based on it to route the queries based on those rules and specify to the host groups. The obvious one is to divide the host groups between writers and readers. and route them based on if they are select to the readers, if they are not to the writers. One of the features I like about proxy skills is that you can push the changes on the fly. You don't need to reload or restart. You can push it into the runtime configuration and it applies right away. And it provides clustering options. Proxy SQL clustering. You can cluster different proxy SQL nodes into a cluster, and that opens up different possibilities. So, discussing the benefits of proxy SQL maybe needs its own presentation, but for the sake of the time, I'm picking up three benefits. So for developers, they connect. You can make using proxy SQL. You can make them connect to a single URL, and you don't care about what's happening in the back end in the database side. Proxy SQL divides the queries or reroute the queries based on the query rules the DBA sets up. Query caching. There is an interesting story with query caching. It might be not an obvious benefit for proxy SQL, but I have seen use cases where some applications will be hitting the database over and over several times within the second against exactly the same table, which has minimal changes. It really gets changed, so it keeps doing the round trip for exactly the same data. You can do query caching in proxy SQL and save the data and define the refresh rate, and during that time the information is right there, and I have seen significant improvement in the application side because of that. So that's why it's in the top, in the not top, but in the 3 points I thought to include. For DBAs, the proxy SQL has its own monitoring capabilities. It's implemented. You don't need to add your own scripts or ways of confirming the health of the MySQL nodes. It's compatible with automatic failovers, as we will see soon. Obviously, the scalability options it provides. Again, those are just a few points I thought to include for this presentation. The setup of proxy SQL in this presentation, or at least the points I will be discussing in the coming up slides, setting up the interfaces, enabling monitoring, using the read-only check to define the host groups or which host goes to which host group, using PT heartbeat for lag monitoring. During the preparation for this presentation, I used a recent version of proxy SQL, run into an interesting problem, which made me use a scheduler to fix the problem. So I'll be discussing that, adding a scheduler to work around it. Disabling the writer is also a reader. There is a way you can enable that or disable it based on your needs. And finally, setting up the proxy SQL cluster. Okay, so the interface, the default setting is the port is 6033. It's just, I think, a way of making sure you don't conflict with an existing proxy SQL on the same node, I assume. But you can configure it into the default MySQL. That's what I have been using, and it made sense to me at least. I'm dividing it into centralized and decentralized. The centralized is basically a hub in the middle where application will connect to the proxy SQL connects to MySQL. Decentralized, proxy SQL is set up in the application side on the same host. In some cases, I needed to make the application believe it's talking to MySQL. So for simplicity, I provided exactly the same socket as MySQL, and the application, minimal changes in the application side. It talks to proxy SQL as if it's talking to MySQL. nothing complicated here. Those are default options. Monitoring is enabled by default. You have the username and password defined as monitor by default. Again, make sure to change that in your production environment. There are many different monitoring options and variables that you can check with this query. This is the link to the documentation about monitoring if you want to fine-tune how frequently and how often it checks, and some options regarding the replication lag. The user doesn't need any wild permissions, usage and replication client, to check for the replication lag. Okay, so using the read-only check, ProxyScale provides a table that, based on the information you provide, would decide each MySQL host belongs to which host group. The table is MySQL replication host groups. You define the writer host group and the reader host group, and what check to use to define which the host go to which host group. And comment just for easy reading. So I'm defining my writer host group as 0 and my reader host group as 1, and the check I'm using is read only. So ProxyScale will check if the host has read only on or off. If it's off, then it's a writer. If it's on, then it's a reader. I mentioned earlier that with ProxyScale you can load your configuration to the runtime without having to restart or reload. This is the command that you will use. There are different options that you can use for a check, including NUDB read-only, super read-only, a combination, and or. So you can read about this if you think you need one of them specifically for your use case. Configuring BT heartbeat, it's a basic configuration, the same as any BT heartbeat. You create a schema, you create the table, you guarantee the privileges, or user will be BT heartbeat in this case. In ProxyScale, you need to add the user. ProxyScale, any user that connects through ProxyScale will need to exist in ProxyScale as well. So you define the user, BT heartbeat, password, and you want the default host group to be 0. As I mentioned earlier, 0 is the writer, and because BT heartbeat writes to its own table, you need it to be pointing to the writer. Specifying the default host group, make sure that the connection goes to that default unless it matches a query rule. The second option you need to set in ProxyScale is to enable Percona heartbeat. There's a specific variable for that, and as soon as you provide the schema and the table, ProxyScale figures out that this is how you want to check the replication lag. These are the configuration I used for the BT heartbeat. I got it from a Percona blog that you can reference. It has really interesting argument about setting up ProxyScale with BT heartbeat. It was written by David and Ivan, and they discuss a problem that I found was resolved in newer version for ProxyScale regarding the replication lag being enforced even for the master, for the writer nodes, which caused problems. I didn't see that problem anymore, but I found a different issue. After a failover, sometimes ProxyScale gets confused, and apparently the reason was because there are more than one entry in the BT heartbeat. The old master has its own entry still there. I haven't looked into it deeper. I came across it as I was preparing for the presentation. This solved the problem, whether it's the best solution or not, but basically I'm checking if there is more than one entry in Percona heartbeat. If there is, delete anything that's not the current master server ID, because this will go to the writer, because the way query rules is defined, or I defined it as that if there is a select, it will go to the reader. By default, BT heartbeat anyways is going to the writer. So this is going to the master. The server ID will be the writer server ID. Although it might be best to save the server ID. And anyways, I'm not going to think about this now, but you could pick up the server ID and make sure you put it here, because this will anyways, let's not get into this now. So basically, there's a link here to an issue. There have been a change in the way proxy skill queries Percona heartbeat table using min instead of max, if I'm not mistaken. So that changed the behavior, and this is one way to solve it. Just keep an eye for it, make sure you test it, and implement a solution like this if needed. If you need a scheduler, like in this example, you just insert into a scheduler table, which you can specify the script you need to run and how often. I'm running it every second. Maybe it's aggressive, maybe it's not. You can specify if it's active or not. All right. Clustering. So there are three variables you need to change in proxy skill. First one is the admin cluster username, admin cluster password, as well as the admin credentials. By default, you will have admin, which what you will use to log into proxy skill. So when you have MySQL user admin password admin to log into proxy skill, you need to also add these because the remote proxy skill will connect to proxy skill admin using this username and password. So these credentials need to be defined so that when a connection comes from the remote proxy skill to sync its information or does the check, you need to give it that access. Once these configurations are done, there's a proxy skill servers table that you can insert which nodes you want to sync with. Pay attention to the port 6032, which is the proxy skill admin port, not the MySQL port. Wait, based on the documentation, it's not used yet. I haven't seen any mention that have been used, so don't worry about it. A comment is just for your own reference and easy reading. This is straightforward from the documentation. Basically, so far only these tables are synced, so any changes on this table, if you add a new server or a new user or query rules, etc., will be synced with whatever node is defined in the cluster on the proxy skill server list. There are two links here, one from the documentation, one from the blog. When clustering was enabled in proxy skill, you can reference them for details. Anything outside of these tables will not be synced, but I think this is what matters for now at least. There haven't been anything more than this that needed to be changed, in my end at least. So for this specific implementation, read only needs to be the default in my.cnf, so that whenever a server comes up, it comes up as a read only. It makes sure that we don't get into a split brain. If a node comes up that's registered in proxy skill sees it as up. If it's a writer, if write is enabled, we have a potential problem of split brain and potentially many other problems. All right, so now we have configured a proxy skill and orchestrator. Now, how would this be set up? How does this solve our problem from earlier? So you probably remember this design I showed earlier in the presentation with the configuration that have been made in the previous slides. Now our setup looks like this. So we have 3 orchestrator nodes in the left. Each has its own SQLite, and they are all connected through Raft. Each orchestrator node is monitoring the whole topology. In the middle, we have our MySQL cluster. In the right, we have 2 proxy SQL nodes to avoid a single point of failure. They are configured to sync within each other, so an update one will go to the other. You could probably disregard the clustering point for a simple setup of 2 proxy SQL nodes if you depend in a configuration management tool that pushes the changes to all nodes. It's here to illustrate the idea. As I mentioned in the beginning, a load balancer here is mainly to make sure we don't have a single point of failure in proxy SQL. So put whatever load balancer you prefer, whether it's HA proxy or a load balancer from your favorite cloud provider, whatever it is, because we only care about avoiding a single point of failure. This could even be keep alive D, for example, where you're flipping the VIP based on the health of the proxy SQL node, and the applications will only connect to that point, and the whole point of simplifying the setup and decoupling from the application. In a Zoom, okay, yeah, so going through the changes, whether doing a graceful failover or killing bicycle, I don't recommend that, but we can kick out the old master. Orchestrator takes care of that. Proxy SQL picks up a new node with read only off, figures out this is the writer node now, redirect the connections for writes. Orchestrator have already moved the slaves from here, from node 1 to node 3, and using sudo gtid, this process is really simple. Any alerts or hooks would have been executed. Human intervention goes into node 1, reconfigure it, and rejoins it into the cluster. Application are running fine. No changes needed in the application side. This is all done with orchestrator and proxy SQL managing it in the background. A zoom in view just in the proxy SQL side. Basically, this is host group 0 based on the read only off and read only on. The synchronization here is in 2 ways, and if you want, you could add more. This is the part about the scalability. You can add more slaves as you go, and as soon as proxy SQL picks up that node, either with manual insert into the proxy SQL server or through a configuration management tool, it will automatically be assigned as read-only, because if you remember, we have read-only as our default. Now, there is a case when if during a failover the old master comes back online. We will discuss that further in the demo. Okay, so for decentralized proxy SQL, let's say you have an application that is complicated to change, and you still want its own, it still needs its own proxy SQL, or sorry, MySQL node on the slave itself, or sorry, on the application side itself. You can basically configure proxy SQL to be in the node using exactly the same configurations we had before. The only difference would be if it needs the MySQL socket. You remember that from earlier in the interface slide. You can provide a socket that mimics MySQL, and the application will pick it up normally. Same use case, same failover process. If this guy goes down, the other one will be picked up. The only problem with this is that you have more, depending on how many of decentralized setup you have or decentralized implementation you need to push. You have more nodes to configure and more nodes to manage. So you will need to find a way to manage each proxy SQL node. It might be a configuration management problem, but this is something to consider. Again, zoom in. As you can see, it's exactly the same concept as earlier, except here we have proxy SQL on each node. What I call a hybrid proxy SQL is basically combining the previous two solutions. This potentially could solve the problem we had in the second case for local proxy SQL, where we can configure the local proxy SQL to pull the configuration and the users and the servers from our centralized nodes. Let's say we have some application that would use the same cluster that needs still need its local MySQL, or for whatever reason proxy SQL needs to be in the application side to avoid extra hops. Whatever the case is, there is a way to configure it this way, and in that case you only have two nodes to manage instead of X amount of proxy SQL nodes. Another possibility is, and this is theoretical, I haven't played with it yet, but I can't help it but think this could be a very good use case for Kubernetes. If you want the application to connect to MySQL instead of worrying about the whole stateful problem, push proxy SQL and make it pull the configuration from existing nodes that's defined in your pod configuration. Something I hope I can play with sometime very soon, but it would use exactly the same concept with a one-way sync, because proxy SQL clustering allows both options, two-way sync or one-way sync, depends on how you define your proxy SQL server lists. All right, so this is brings us to the end of the presentation, where I'll be demoing the first use case, just a very simplified setup, just to illustrate how this works in real life. All right, so as you can see, we have the orchestrator on the left here, and as we mentioned earlier about defining the DCs, you can see them defined here, DC1, DC2, based on the naming here. That's the query I was using. I realized I made the mistake of not including the cluster as well, app1 for example, and this might be a good way of demonstrating why this is a bad idea, because right now the cluster name is the master name. As we will see in a bit, this will not default our demo, but it would at least illustrate why it's very important to have a cluster name defined. I was hoping to demonstrate intermediate master failover as well, but given the short time left, I'll only be doing a master failover. Would have just moved these slaves around, put it for DC2, put them together as slaves, and make this intermediate master. So just showing you how simple it is to deal with orchestrator. Of course, be extra careful when it's production. Okay, so we have proxy SQL in the top here, and this is the current acting master in the bottom. So if I check the runtime MySQL servers, it's important to check the runtime to know the status of the current MySQL nodes. So I only defined these, as I said, I'm only doing this side of DC1 of the implementation, but it's the same concept if I move further. And let's kill the active master. All right, I'm on the right host. Yep, Okay. All right. There we go. Started the failover, and proxy SQL is showing node 1 as shunned. Sometimes orchestrator web interface sometimes is slow. As you can see here, it may still take some time to rebuild the topology graph. So don't worry if you don't see it right away. So DC101 have been kicked out. There is nothing underneath it. And now we have another cluster. As you can see, the cluster name has changed. And this causes a lot of problems if you are doing automations. So if I go to the dashboard, I have two clusters, one solo, and my cluster here, which received the promotion. Now DC2 is the new master, and if I start MySQL again here, DC1 will show online. It's timed out automatically. It's still shunned in proxy SQL. I have been running continuous select on the back. No connection is going to node 1. It's running every second. And there are no connections running on the back end. The reason is, if I go to MySQL, dot heartbeat, from, if you can see, the timestamp is not changing. And this way, the host, proxy SQL detects that this node is behind, and I will not include it in here. So I need to recover this host manually and make it rejoin the cluster again. If you remember earlier, I said you need to acknowledge any recovery. You will find it in recovery, and you go here to acknowledge it to allow for another failover to happen. The last thing I wanted to mention is DC2 was not promoted because I have a rule that says do not allow cross DC failover. Another thing I wanted to mention, in the same page where you acknowledge, it does give you the breakdown of the recovery steps. You did see that it took some time to refresh the page, the web interface. However, here it gives you exactly the breakdown of the recovery. And you can see the second it started or detected the problem and when everything actually completed. So the process actually took a second. It's just that the web interface takes some time to rebuild. And here you can see exactly each step. Remember that I mentioned earlier about the hooks. See, it goes in that order. Running one pre-failover process hooks, which is the default. It explains to you exactly what it did. This is what it ran, and that's why it's important to make sure it's quick. It doesn't even give you how long it took to execute the pre-failover process and then the actual recovery. So if this took long time, it will delay the recovery process. It tells you exactly what type of recovery and what it did, regrouping, and you can read through this to understand exactly what decision it took. And this is again something really great that Orchestrator provides. Okay, this takes me to the end of the presentation. Thank you so much for your time. I hope you find that valuable and it added some benefits. And I would like to hear your feedback. I want to take the opportunity to thank the teams behind Orchestrator as well as ProxyScale for the great products and great contribution to the open source community. Also, I want to thank Percona for their continuous support of the open source community and for holding this presentation. And thank you so much.